Wanted to welcome you all. It's 1 o'clock and therefore time to start. For those of you who haven't noticed, I'm definitely not Tom Wheeler. Tom seems to have another role that he is pursuing, so he chose not to join us. And in his absence, poor substitute, but I'm delighted to be filling this chair. We do have a number of new members around the table today, and so just want to introduce a few of those. Some are friends from a long time past, and let me just introduce those around the table, and I hope they're all here. We'll have to determine that. But Mark Brigman is here from Neustar, the Chief Technology Officer for that enterprise. Is Brian here? Brian Fontes? I haven't seen him.
Brian Fontes.
Fontes?
Empty chair.
Oh, there's his empty chair. Yeah, got it. Although he's been with us for really quite some time, he's official now, official in his chair, and this is Pierre de Vries from Silicon Flatirons. This is going to be the challenging one, and he knows that. Ramani, and go ahead and give us your last name so I don't murder it. Pandurangan. So Ramani is here. He's VP from EXO, and so we're delighted that he is here. In addition, though he is being represented, we'll introduce Bruce Gustafsson, who is the Government Affairs Officer from Ericsson. And he is here as a representative today, so we're glad to have you here. Did I miss anyone who is new to the group? That's a good thing. All right, we do have a very special guest today, and really honored to have adjacent to me on my left our real chairman, and we're delighted to have our chairman of the FCC, Chairman Clyburn, here with us. And so in her first meeting with us, I'd like to very quickly run around the table and have everyone introduce themselves very briefly, just with your company and your title, and that'll give you a quick view of who's here around the table. So,
Michael Ha, FCC staff.
I'm Paul Steinberg, CTO at Motorola.
David Clark from MIT.
Jeff Mendenhall, Harris Broadcast.
Ramani Pandurangan from EXO Communications.
Mark Richer from the Advanced Television Systems Committee.
Marvin Serbu from Carnegie Mellon University.
Jack Nishelski from Qualcomm.
Jorge Gomez, representing Shahed Ahmed from Accenture.
John McHugh with NTCA.
I'm Greg Lappin from ARRL.
Dick Green from Liberty Global.
Adam Zerobot from Open Tech Works.
Lynn Claudy, National Association of Broadcasters.
Mark Bregman from Neustar.
Ed Chan from Verizon.
Milo Medine from Google.
Mark Bayless from Visual Link.
John Barnhill from Ginband.
Bruce Gustafson from Ericsson, representing Vision Anglo.
Joe Wetzel, Earthlink.
Pierre de Vries, Silicon Flatirons.
Kevin Kahn, Intel.
Gregory Chang, Yumi.
Charlotte Field, Comcast.
Jack Waters, Level 3 Communications.
Henning Schotzoni, FCC.
Dale Hatfield, University of Colorado.
Julian Abt, FCC.
Really? And I believe, in part due to the weather, and I should have probably prefaced all of this with many thanks for all of you being around the table, because I know the weather has been an enormous challenge for some of you in getting here. But based on the weather, we do have an open phone link for a couple of our members, and I am hopeful that some of them are on. Nomi in particular, I know you were trying to be on. Are you there?
Yes, I am, Dennis.
Oh, you are. Great. Introduce yourself.
Sorry, I'll have to mute if I'm ever going to talk. Thanks, Dennis.
And she's the CEO for Bright House. Are there any others on the phone line?
Devin Parekh. Devin Parekh from Insight.
Welcome.
Marty Cooper's on.
Brian Fonts.
Great.
Brian Fonts, National Emergency Number Association.
Okay, so you are there, Brian. Juniper Networks.
Harold Teets, TW Telecom.
Any others? Well, welcome on the phone lines. We actually have not used that in the past, so we're delighted to have you here, if not here physically. Again, we are honored to have a very special guest in our midst, and I would like to offer the opportunity for Chairman Clyburn to say a few words to the group now that you know each and every one of them.
Thank you so very much, Mr. Roberson, for welcoming me here, and to all of you, some we don't say old friends, we say mature friends, and and new friends. Again, welcome and thank you for serving. I chuckle a bit because you, Dennis, you have the role as acting chair.
Yes.
During the cable show a couple of days ago, former Chairman Powell made it clear that there is no such thing as acting when it comes to chairing. So you are our chair, and we really appreciate your service. Former Chairman Janikowski reauthorized the tax charter earlier this year, and this action was a clear testament to the value you all bring, not only to this council, but to this agency. Your input and technical expertise are central to the Commission in identifying key areas of innovation and developing informed technology policies supporting the United States' competitiveness in this global economy. I know the TAC has been very active on a wide array of critical issues related to telecommunications and broadband. It has provided several thoughtful and forward-thinking recommendations, and the FCC has already taken action on a number of key items. For example, with regard to your recommendations on small cell deployment, the FCC issued a notice of proposed rulemaking on small cell use of 3.5 gigahertz spectrum. Small cells and distributed antenna systems are crucial to meeting the growing demand for mobile broadband. As the President's Council of Advisors on Science and Technology, always known as PCAS, highlighted in its Spectrum report last year, moving to smaller cells could provide as much as 400 times more wireless network capacity. Earlier this year, the TAC issued a white paper on interference limits for wireless devices. With greater demand for spectrum, we must promote more resilient and efficient radio devices, which will result in more reliable communications and help make for more efficient use of spectrum. The FCC has also acted on several other TAC recommendations related to accelerating broadband deployment, creating new metrics for measuring broadband performance, as well as facilitating transmission to IPv6 nationally. While much has been accomplished, I know the TAC will remain very busy this year. You have established 5 working groups to tackle essential and timely issues that directly impact consumers. It is my understanding that these working groups will look to identify higher frequency spectrum bands above 30 gigahertz for wireless broadband, and how commercial broadband networks can be better utilized for emerging services such as smart grids and intelligent transport systems. It will also determine key areas related to improving broadband network resiliency and cybersecurity. And of course, TAC will continue to focus on initiatives to improve efficient use of spectrum. So I look forward, along with my colleagues, to following the activities of the TAC and considering those future recommendations that I know will come from this impressive body of experts. And with that, I will turn this meeting back over to its most able chair, Dennis Roberson. Thank you.
Up until the last piece, I was absolutely tracking.
Okay.
No, it is really terrific to have you here with us, because we do recognize that you have an extraordinary schedule right now, and especially with 2 commissioners down, you not only have the chair role, but you have only 3 people instead of the traditional 5, so your role is even more impacted than normal. So
Thank
again,
you. Appreciate it.
You bless us with your presence, if you will.
Thank you.
And towards that end, and in fact exactly in line with the comments that you've made with our our 5 working groups. What we would like to do is have a brief synopsis of each of the working groups to update our chair of the commission on those activities, and then we'll proceed into a more in-depth review with the discussion amongst the committee. So if we could move through this, and we'll cover the 3-minute version in the same order that we'll cover the activities as we go forward. So Spectrum Frontiers is up first, and Adam, you are on.
So I'm actually reading this for Brian. Mark Walter couldn't be with us today. Okay. Just wanted to say I'm doing this for Brian Mark Walter, who couldn't be with us today. And basically, the group is looking at 3 issues. The first of which is peeking into the future, what spectrum bands have the potential for becoming sort of the future beachfront properties as we go forward. What technical and policy changes are needed to make this possible, okay? And then lastly, considering the time scale on which it takes to actually take a swath of spectrum and making it economically feasible and useful for the future. And in doing that, we took a hard look at spectrum going from the existing stuff at 1 gigahertz all the way into the visible. Because what you find is that spectrum has different characteristics at different wavelengths. So hard look at what's possible there. The group has heard from a number of organizations, including a fairly interesting presentation from Samsung, looking at some advanced antenna technologies, things along those lines. And then I think basically, I think what we're concentrating on is what is it that makes a complete ecosystem for a piece of the spectrum so it can be used to sort of take on the load that we're seeing on the demand end at this point, okay? And so the group will be looking at a lot of advanced technologies, things that are there for broadband, things that are there for spectral efficiency, and then finally, how do you improve communications, possibly at short ranges, so in a hierarchical system all the way from the home to sort of continental distances. Okay? And I think the group is probably at a stage where it's considering more of the questions at this point, and we'll be filling in over time and hopefully have a report by the December time frame that makes some recommendations. Okay, thank you. Any questions? Good.
All right, for our second group, this was going to be a game time call. Our second group is looking at wireless COTS, if you will, and Shahid Ahmed has been the chair of that group. He is still traveling this way, I understand, will be arriving momentarily, but in his stead, Jorge, would you like to introduce yourself, your role, and take the lead in the 3-minute rush?
Absolutely. Good afternoon. My name is Jorge Gomez. I am part of Shahed's network practice at Accenture. The task group that Shahed is leading this time around is on the main objective is on the expanding of wireless commercial off-the-shelf technologies for a select number of industries. Particularly, we'll be focusing initially on the utilities industry, government, including federal, state, and local, and defense, as well as healthcare and transportation. The main objective of the work group is to provide recommendations and find ways to leverage the technical and commercial benefits of scaled wireless solutions or commercial off-the-shelf technologies to lower the cost of entry for wireless applications, speed up and accelerate growth in wireless network adoptions, limit the necessity for customized or industry-specific deployments and technologies, as well as spectrum allocations, and increase the sharing of both network resources and spectrum for the benefit of other vertical markets and industries.
All right, the third working group is the Spectrum Receiver Performance Working Group, and since I'm moving into this chair, I suggested to the working group just this morning that it would be really terrific if someone would step forward to take the role of reviewing the activities of the group. And I don't know exactly what happened, but everyone took one step back. And they suggested that I would be able to do both roles and that it wasn't undue pressure on me. And so I find myself, perhaps properly, reviewing the efforts of our working group. We have a very aggressive working group, and I will note now it's actually the smallest of the working groups, but we've taken on quite a large role, especially given the number of individuals. This is an extension of the work that we did last year in some respects, in that we're continuing the work on the interference limits that Chairman Clyburn referenced, and in particular there's a notice that is out now to solicit input on that white paper, and so we'll be sort of looking over the shoulder to see how those responses come in, but also continuing to refine the work on interference limits, and in particular trying to identify some of the details, the harm levels that are important to be able to execute on that concept. Somewhat separate from that, but very much related, is work in the statistical area, as applied to interference limits, but more broadly as well. And this morning we actually had a very good review of all of the statistical work that has been done within the FCC, that is done by an intern at Silicon Flatirons, or a graduate student there. And that was quite interesting and really a very fruitful conversation that is moving us ever more into that area. Those of you who love the statistical approach, I actually saw a couple of heads nodding. You may want to consider joining the group and helping out. And Pierre De Vries, who's been leading that, would be more than delighted to take your name afterwards and get you involved, or I would as well. Second part of the 5 elements is the multi-stakeholder groups focus. And I should, as I've actually already done with Pierre leading the interference limits piece, let me recognize in multi-stakeholder groups, Lynn Cloudy is providing the leadership in that area. And this is actually a part of the interference limits white paper, but the notion that we would use multi-stakeholder groups to be able to refine the directions, again, for interference limits, but for other areas as well, and how to take full advantage of multi-stakeholder groups in that area. The third area is one that we had put forth last year as well, which is now been expanded. It was receiver standards, now it's radio system standards and specifications. And the notion that we take advantage of the existing FCC representation of the work that is going on, or the usage of the spectrum, the dashboard that exists on the website, and put more depth into that by capturing standards, capturing specifications, again originally focused around receivers, since that was our charter last year, but we've recognized that it really is the systems that are important, and so we have jumped into that in a big way, and Greg Lapin and Jeff Mendenhall have been providing a lot of the leadership for that work. The fourth area is in emerging technologies. Can technology solve all of this quite independent of anything that we do from a policy standpoint? And that's always the one perspective. Never quite gets there, but certainly is an important factor in all of this. And so we're diving into and better understanding the emerging standards, the opportunities, for instance, to use a single channel for communications going both directions at once, so send, receive, looking at how software-defined radios are applicable in this area, looking at the whole notion of crowdsourcing for information to understand the usage of the spectrum. The final area is one that Dale has provided leadership on, and one of his recent favorite subjects, and that's enforcement. All very good and fine that you've put all this in place. How are you going to make sure that people are abiding by the rules, that people are actually following through? And so we're really digging deeply into that area, and those are the 5 areas. All right. Flipping hats, returning back to the oversight of the meeting. Our next area is resiliency, and in the absence of Russ, Henning, or you're this way, Henning will provide us with the oversight on our resilience work. And this, if you recall, was the most popular of the working group topics. More people spoke to this topic than any other by a good margin. And in fact, it is also the largest of our working groups, with 24 members on the working group. So Henning.
Thank you. Unfortunately, Russ is still in transit as far as I can tell, so I'll take on the summary task. Today's weather forecast is a good indication of a motivation for the working group. I hope we don't get to add another example to the list of previous incidents that have illustrated both the opportunities and challenges in making communication networks more reliable and resilient. That's not a new topic. It's probably one of the oldest topics that both the Commission and outside entities, corporate entities, research labs, standardization organizations have worked with. However, there is a perception among the committee members that we now have an opportunity to look at that topic again because there are new technologies available that allow new approaches to resiliency. In particular, where in the old days most entities, private and public, as well as corporate, had essentially one wire going into the house, one twisted pair. Now we have typically a cable connection, a landline, voice type of connection, twisted pair, DSL. We certainly have 3G, 4G. We have satellite in many cases. All of these can be leveraged to facilitate resiliency. Also, we now have clearly a transition happen to Internet protocols, which in some cases make it much easier to make multiple systems appear logically as if they were one system. Thus, the resiliency group will be looking at those new opportunities as well as how to make the existing infrastructure that is being built, particularly, say, fiber access networks in residential and business application, more resilient, and to identify particular weak points that we can address. A related aspect is the ability to measure reliability and resiliency. One way to measure that is during an incident itself, so that you have a situational awareness as to how well your infrastructure is doing, where particular assistance may be needed, and how coordination can accelerate recovery. But also to be able to predict ahead of time as to where particular weak points of the infrastructure may be, so that those can be identified not by trial by fire and wind, but really on a simulation setup ahead of time, something we were not as able to do a few years ago. So the group, a very active one, looks forward to producing a white paper by the end of year deadline, which will look at those issues, as well as another one that I haven't mentioned, namely the ability to prioritize certain high-value communication in those new environments. We've always had a system called GETS and WPS for voice, very voice-centric model. It's clearly now for public safety and other applications. We should probably look at extending that to more data-centric applications as well. That's my brief summary.
Very good, Henning. Thank you. Henning's done a lot of the heavy lifting in moving this group along, so thank you for presenting. Our final group of the 5 is communications infrastructure security, which has been very much in the news of late, very hot topic. And the chuckles, not at all sure what you're chuckling, but Paul, please
So we're not planning to take that onto our charter at the moment, Dennis, if that's okay with you. So Greg and Ahmed, our FCC liaisons, helped us narrow up a little bit because that's obviously a massive topic. And we've narrowed the scope up to around cloud infrastructure security, which seemed like a good thing at the time when we thought that was nicely focusing, until we started to look into it further and found out that it's a very vast topic in and of itself. The major objectives that we have are, pretty typical. Identify the concerns that are out there, surveil the industry groups and the opportunities for collaboration with the FCC, identify the key gaps, then, of course, ultimately conclude in recommendations for the FCC and how they might facilitate this important task. A quick look at the landscape told us that this is a very hot and active topic. Tens of groups involved in the U.S. government alone. Probably more than tens of groups involved in research and academia, standards associations, many of them have a dog in this hunt as well. And finally, there's a great deal of international work going on in this space, all pulling in the same direction. So there's a lot of material for us to kind of wade through. One thing that we led ourselves to quickly was a group known as the Cloud Security Alliance, which is specifically formed around this topic from an industry point of view. And we brought one of their COO, John Howie, in to give us a bit of a briefing and to help us, kind of understand the needs in the state of the art in industry. And that was extremely helpful to us. They have what they call the Notorious 9, and he was able to help us understand that there's a difference between the threats to cloud users, and that is the Notorious 9, and then there's a threat or an impediment to cloud adopters, and they aren't the same threats. So that alone in and of itself causes us to think about this differently. So ultimately what we settled up on was a division into 3 working groups. The first working group is around consumer and commercial clouds, and that leads us more toward the public hybrid type of cloud topologies. And if you push underneath that, then there's a number of permutations of how clouds can be deployed. Infrastructure as a service, platform as a service, software as a service. So there's a number of different ways that the industry and cloud service providers actually realize this. Second group was around critical infrastructure, and that seemed to parallel nicely the executive order that was issued earlier this year. Obviously, critical infrastructure is a cloud user as well. And that tends to lead us a little bit more in the private cloud domain. So that gives us some coverage across the 3 major cloud topologies. And then the third group sort of cuts across the 2, and that's cloud access. So it doesn't do you a great deal of good if you secure the cloud and the content in it, but you don't have a secure path to the cloud and the ability to move data to and from it in a secure way. So those are the 3 groups that we've set ourselves up to organize around. And our plan is obviously to get scoped and get a lay of the land, which we've got a reasonably good handle on now, and I think we know who we want to pull in to continue to advise us. Now it's a matter of just simply assessing and identifying the key gaps, and then finding those that are most applicable where the FCC can definitely make an impact, and then ultimately conclude with the recommendations to the FCC.
Great.
Thank you.
Thank you. Hachid, welcome.
Sorry I'm late.
No, you're not alone with the challenges with the weather. So you now have the warm-up, and this not only was, I hope, was helpful to you to give you a perspective, Chairman Clyburn, but also I think helpful for the whole group. So this was the warm-up exercise. Now you've done your calisthenics. You're ready to go. Those who are new members to the group, you now have a lay of the land, and if you have not already become firmly entrenched in one of the working groups, hopefully you will very shortly, and if you have discovered through this and through what you'll see in the rest of the meeting, another group that you'd like to be involved in, that's an opportunity as well. So you'll be able to be here for a while longer, or
just a
few minutes? Okay, great. Any?
No questions.
No questions or comments. All right, very good. Well, then let's jump into the more in-depth review and afford the opportunity for discussion that is associated with that. And we'll take it back to the top. And Adam, you are now back on with having put the appetizer behind you. You can now move into the main course. While you're preparing, I will remind everyone, and particularly those who are new to the group, that as you have questions, the approach to establishing the desire to speak is to raise your tent card, and I'll try to call on you in appropriate timing. And if you have questions of substance as the presentations are made, please ask them. If you have more general comments, maybe hold them till the end, and and that will stimulate further discussion. But we want to have adequate time for that, so each of the speakers will try to conclude in 15, at most 20 minutes, to allow 10 to 15 minutes of conversation and discussion afterwards, which is a lot of why we get together, so that we can have those conversations. So with that, Adam, you're on.
Are they going to put the view graphs up on the screen? Or?
Yes.
They are up there right now.
Okay, super.
Adam,
Okay.
we have a new system that if you want to advance the slide, just blink your left eye. The system was detected and moved the slides.
Adam, do you have a Twitch?
It's a new app.
How do I go back? And if I'm cross-eyed.
You're not going to let him do it, huh?
Take some practice.
Okay. So
This is the Michael system.
Absolutely. Okay.
It's a prototype, so there's a lot of manual involved.
We're grateful for your invention.
Thank you. Okay. So let me go on to the. So this is the Spectrum Futures Working Group, and let me start off from the top. That we're looking at really three issues. The first one is again peeking at the future. What spectrum bands have the potential to become new beachfront properties, essentially? What technical or policy changes will be needed to make this realizable? And then what is the time frame in which this might happen? And the chairman of our working group is Brian Markwalter, and very ably assisted by Michael Ha and John Leibovitz from the FCC. So in terms of what I would like to be able to cover today, and this is our agenda, is to look at the innovations which enable more efficient use of current spectrum and often allow utilization of higher frequencies where the economics can prove out to be reasonable. And one example we have of that is the use of smart antenna technology. Okay? And basically, what I'm going to look at is an overview of what higher frequency bands are available, what the key FCC allocations are in the millimeter wave bands that already exists, mobile broadband applications that may be possible, the license status of some of the higher frequency bands. I think there's quite a bit of experimental license work that's already going on, and then we will take a look at some future policy considerations. So if you look at the chart that's up there right now, we started off with a very broad view of things, looking from very low frequencies, literally going up into the visible. And the way we characterize things are, where is the spectrum, various parts of the spectrum, where are various parts of the spectrum useful? So you can look at the range, building penetration. While we don't have it on the view graph, things like foliage, whether stuff propagates well or it doesn't. And then the characteristics of the devices that go along with it, cheaper terminals at some of the lower frequencies that we use for cellular today, the promise of even smaller devices if you go to much higher frequencies, and basically the use of what I'd call connectivity at short range. If I look at what came out of this, is mobile broadband at 30 gigahertz as a specific focus area, the use of things around 60 gigahertz for unlicensed ISM, and then that whole swath of frequencies between 100 and 300 gigahertz, because if you take at our use today and the demand that's there, you're talking about not adding, I would say, tens of megahertz. It's literally hundreds and hundreds of megahertz that are made available if you can do something useful there. And then lastly, I'd say optical-like communications, and actually identified a number of groups that are working in those areas. So if you look at the next chart, I'm not going to spend a lot of time on it, There's quite a bit of licensed spectrum that's out there that actually goes up to higher frequencies. While those frequencies have been allocated, when you start taking a look at the license status, I think the next view graph, in fact, has the inventory. And what you'll find is a lot of stuff has been granted. It has all kinds of rules built around it. And a considerable amount of spectrum is actually being turned back in. People are abandoning those licenses. And so that sort of poses the natural question of, what is it that should be done on the policy end and on the rulemaking end that really encourages people to do a complete build-out and create ecosystems that really make sense. Okay, so this is one of the areas we're going to study in a little bit more depth to make sure that we understand the patterns. We have asked a number of outside organizations to come in and give us a briefing of what they're doing technologically. So I think the first of those presentations was, I believe, from Samsung. And they were looking at stuff around 30 gigahertz, looking at short-range use, essentially. And what's interesting here is that there's activity outside the U.S., not just here. And so the question is, if you start looking at some of these forward technologies, how do you make sure that you're on a path to end up with harmonization as you really go along, essentially? Okay. And then we looked at an example. This one was from IBM. Tiny little array. It's an 8x8, and that's all the way up at 90 gigahertz. So it tells you that there is quite a bit of movement in technology. Probably not at a stage where stuff can actually be deployed today. We also took a look at some of the unlicensed bands and industry-specific uses. So, for example, radars for things like cars, where you're doing collision avoidance, automatic parking, things of that sort. And again, it sort of begs the question again, what is it that we do in the U.S. if 48 countries have already adopted a standard, and what are the issues about that? So I would say the group as a whole is sort of in a study stage of the issues, again, looking for places where one can bring some technology to the table or some policy recommendations that make sense. Also quite interesting, a lot more experimental, is the stuff between 30 and 275 gigahertz. You can buy components today, a lot of experimentation going on. Not to say that you could build a practical system today, but looking into the future, again, huge swaths of spectrum, some of it having academic uses, some being natural observations, things of that sort, but lots of holes in there, some good places with their reasonable propagation characteristics, and again, we see if the demand continues, how one could actually exploit these higher frequencies. So if I were to sum up, we're going to take a hard look at some of the stuff in the visible space. There's something called the Li-Fi Alliance, for example, that's looking at that. The promise of smart antenna technologies, I think, really for two outcomes. The first is what can you do to improve packaging and devices of this sort and end up with much better spectrum efficiency, essentially. And then the next is at higher frequencies where you have more path losses, things of that sort, where beamforming is important. What can the technology do? And then again, how do the rules that the FCC has specifically deal with these more complex antenna systems, essentially? Okay. And then I think at the last part of this is how do you make potential use of a national solutions in the millimeter wave mobile bands where you have short range but you have tremendous capacity. So when you start seeing our systems densify, is there some kind of a natural hierarchy where you could use multiple frequencies, some for short range, some for long range, and plug into the national backhaul system essentially. Okay, so if we then look at what are the policy considerations, the first one is if there's anything promising here, how can we put forward a set of policies that will actually accelerate and incentivize the development of adoption at these higher frequencies? How can spectrum be made available in such a way so you actually do end up with a commercially competitive ecosystem with what we already have? I think the issue of harmonization, I think I've brought that up a few times, and it affects everything from your supply chains to the economics of scale. And I would say the last one is the trend to incorporate radios of all kinds in all kinds of equipment, and how would you go about, in fact, making that possible? Okay, so I think I'll stop with that and ready to answer questions for the group.
All right. Terrifically interesting area. Obviously, this is a large part of the future is moving up, as it has been in the past. As we think of the history, it always seems that it's that frequency that's out beyond the horizon that becomes, as you've stated it here, the next beachfront property. So what questions do other members of the TAC have? I haven't seen any cards.
Yeah, there's one.
Ah, there you go, Paul.
Your peripheral vision's not good.
Yes,
Dennis.
yes.
Got to work on that.
Thank you.
So this is, Adam, this is maybe just a test of scope. There's a lot of spectrum out there, and I think Dale has pointed this out a few times as well, that is, maybe not used efficiently. And I don't want, I'll pick an example, but please don't home in on the example because I don't really have a judgment on it. But some of the radar spectrum and some of those kinds of things. So the question is, are you also looking at, is there a way to reuse some spectrum or co-use some spectrum as well?
So what I would say is that there may be two views of this. If you look at the PCAST report, okay, I think what it actually suggests is a totally new view of how you'd exploit spectrum.
Right.
What goes along with that on the technological front is the technology ready, okay, to have multi-band devices that automatically work and transfer and hop around and things of that sort.
Sensing.
And I would say that's very much, on the plate essentially.
Okay.
Okay? Because without that technology, I think just mandating it isn't meaningful.
Yeah, okay.
Okay?
Got it. Thanks.
Oh, there we go. Henning?
Henning?
I'm working my peripheral vision now a little bit.
Just a curiosity question that in terms of, you mentioned propagation characteristics.
Yeah.
For those of us who are not RF engineers, could you just give a rough notion as to what distances we're talking about for many of the bands that you're talking about? Talking indoor, a few meters, or are we talking outdoor, a few tens of meters, that type of thing, or longer than that?
So let me define. You asked a complex question, and let me take it from the top the following way. The first thing you worry about is what does the atmosphere do to propagation? Okay? And what you find in, just very roughly speaking, up to around 10 gigahertz or so, it's pretty transparent. And then slowly going up to 20, you get more and more absorption. You have very specific bands, for example, around 35 gigahertz, in the 40s, in the 90s, where you get dips, okay, because the main absorption isn't there. So there are things like water molecules, oxygen molecules, et cetera, et cetera. So you got to take care of the physics of that. Okay. Then you find that you get very strong absorption until you come to the visible, and all of a sudden the atmosphere is transparent again. Next layer, weather comes in. If you want to build a system that's available all the time, and you get absorption in adverse weather conditions, you can't build the system that way. Okay? So you bring that in. Then there is foliage, the orography that you have to be dealing with, things that propagate well around corners and things that don't. Then you get to buildings, okay, and then it matters how the buildings are actually put together. So what you will find is at some of the higher frequencies, You can't go through foliage, but you can go through walls. Okay? So let's say at 35 gigahertz, I can go through concrete for a reasonable distance. I can go through sheetrock, things of that sort. May actually be good for those uses. So one of the things we're doing as a group is actually trying to sort out what's good under what set of conditions. But it's a very, very complex setting, essentially. Okay? So I hope that illuminates it a little bit.
Thank you.
But the Rangers are, really this makes what I would say is a really hierarchical system. Okay? In other words, for long distance backhaul, I may be better off using fiber between cell towers, not using any frequency, getting stuff off the air as fast as possible. Okay? For the access stuff, one thing. For devices inside the home, I may use something else. Okay? There really is a plethora of uses in this. So I would say the working group is still going through the process of how do we narrow the targets of what makes sense for us.
Okay, Pierre. Oh, Shahir, was you up first? Okay.
I can go first. So, Adam, a couple of questions. Are they any? You mentioned countries, but at the same time, I think you winked, so I'm not sure if it's true or not. But are there countries or case examples outside of U.S. where this type of frequency is being used? And the follow-up question, part B, is are there specific applications that you think this part of the spectrum map that could use it as a viable solution? For example, machine-to-machine or Internet of Things. Is that a possible application?
Okay, so let me answer the first question. If you take a look at things that have been deployed in lots of places, I'd say very mature in automotive for things like collision avoidance radar, parking radar, things of that sort. Okay, that's in the high 70 gigahertz range, things of that sort. I believe the Japanese actually built a considerable number of systems, stuff close to 20 and stuff close to 30, okay, commercially deployed. Okay. Lots of technology on the military side in this. So yeah, there's quite a bit of stuff going on. When you ask the second one, this isn't a group answer, it's a personal answer, and it goes the following way. Integration of devices tends to be as expensive as the devices themselves. And being able to have silicon that brings you up to the IP stack makes any application possible. So when you say, am I going to do this for this or that? No, you're probably better creating ecosystems that can be used for almost anything. Okay? So if I were to ask today, what's the internet, what applications is the internet useful for? Because everything is at the IP layer, almost anything. Okay? You just have to make it efficient and make sure that the supply chain is there and that the devices that handle the stack, things of that sort, have reasonable jitter, reasonable throughput, things along those lines. Okay? Okay? But whether it's machine to machine or something else, whether it's healthcare, telematics, I don't think really matters that much. Okay? Okay? I suspect the more general the use of what you can put on it, the more valuable the spectrum.
Yep.
Okay.
Pierre.
Thanks, Dennis. When I think about the higher frequencies, I tend to think about exotic materials. But I have heard that at 60 gigahertz and above, CMOS turns out to be surprisingly effective, more effective than people had thought. Can you give us a reality check on the manufacturability of this stuff?
Well, so this is in fact, I would say, sort of the $64,000 question. Okay, if you look at silicon, it takes you up to some point. Okay. To get reasonable gain at the higher frequencies, you typically go to indium phosphide, gallium arsenide, things of that sort, okay? And those things don't have as big an ecosystem, don't have as many foundries, the cost is higher. Eventually, okay, I suspect something will happen there, but there has to be some big money put behind it to make it happen. Okay? The number of candidate materials is really pretty incredible. Okay? I think the issue really ends up being who's incentivized to say, hey, this is something I see enough business in. I'm willing to build that $10 billion $10 billion fab or something along those lines, so the stuff will be competitive. I don't know whether Intel would have an opinion on something along those lines.
Well, it's not our primary aim these days, but I think we've tended to be continually surprised by our ability to push silicon further than many of the skeptics would have.
Look,
claimed at any point along the line.
I would actually say when I look at silicon, and for example, the ability to manufacture stuff at smaller and smaller scale, you would have thought the methods in lithography would have sort of given up at some point. It's really amazing how far they've been able to take that. Okay. So I think there is a lot of technological development that being able to build materials at smaller scales allows you to do some exploitation that you wouldn't have thought otherwise.
Julie?
Yeah.
I think this is really important work, and one of the things to keep in mind, I mean, we're kind of on the verge of seeing the new WiGig technology deployed. I think we're probably a year or two from seeing it in consumer products and taking off. And those rules at 57 to 64 gigahertz were put in place more than 10 years ago.
Yep.
So as we think about this, not just think about, well, is it ready today, but are there things that we can see where we create opportunities that will encourage people to invest and develop technology? So, I think I never would have thought of years ago, for example, even commercial wireless applications thinking above 30 gigs.
Yeah.
And some of the issues that we talk about today on the propagation side, sometimes we've got techniques like MIMO and mesh networks that we can kind of work around them and still get effective networks. So it really look forward to the work as we go forward, and it doesn't necessarily have to be something that we're going to do and we'll see a result in a year or two. It might be just a long-term investment for the future.
I'm reminded of the kit that we have often talked about as part of our group to create jobs. This is an area where there is enormous opportunity to create industries, not just jobs. So it really is an exciting area. Let me open things up since I don't have visibility. Well, I'll come quickly. To those who are on the phone, if you have questions and would like to pose those, let me give you an opportunity. I'm actually shocked that Marty Cooper doesn't have any questions, since this is an area that seems natural for Marty to interject in. But okay, none from the phone. Then Greg.
Adam, let me return to your discussion of propagation. Without getting into, like you said, a very complex topic. One thing when you play around with high-frequency propagation or gigahertz propagation is that you think that you've got a signal that goes within the neighborhood, and then one day you find that
it ducts all over the place.
Well, that somebody 1,000 miles away is hearing it.
Yeah.
That's very exciting for an amateur radio operator.
Ducting is a good phenomenon.
But I imagine if you design a system to avoid interference because you're assuming a certain distance, that could be very disruptive. So I just want to suggest that you consider those kind of things as well.
Absolutely.
Good. Yeah. Even using my peripheral vision, I see no more tent cards. I haven't heard anything from the phone line, so let's move on. Thank you, Adam, for great talk, and for the group for great work in a truly exciting area.
Yeah.
So, Sheeta, again, welcome, and thank you for enduring challenging travels to get here. planes, trains, and buses? I don't know.
We need a TAC group for the FAA at some point. Help them out a little bit. Right. It's pre-TSA, I might add. All right. So I assume everyone has heard the preamble through my colleague Jorge. So I won't really delve into the some of the high-level definitions, but I do want to walk you through the process we're embarking on, the deliverables we plan to produce, and what our end goal is with respect to this COTS group. So first and foremost, I think we can go to the next slide, please. Here's the list of members of our TAC subgroup. We've got a really nice cross-section of companies represented here, everyone from the service provider sector to the network equipment segment, as well as some very interesting new entrants like Oceus Network, who we'll talk about a little later, who have a common platform supporting multiple applications. So that is sort of the list of folks involved in our COTS subgroup. Here's the mission statement. It's fairly simple, but I think it's worth going through what we're trying to solve for. So essentially, we're looking for a lower cost solution for multiple wireless applications, whether it's public safety, military, education, park service is one example of a use case around COTS, telematics, healthcare. There's a multitude of solutions out there, and we believe that there could be a common platform for some of these applications and vertical segments. So that's the whole premise behind this COTS working group. We will explore some of the specific use cases and segments in terms of what are the impediments, barriers to entry, what are the commonalities between various different verticals that could essentially become the building block for a COTS product. So we're going to look into some of those issues, including the scarcity of spectrum. So Adam will hopefully work together again in looking into that issue. Next slide, please. Sorry. Let's go to the next slide so we can get into the. There you go. Thank you. So here's the approach. We really laid out 4 large milestones for us over the course of next 4 to 6 months. The first one is around identifying target list of companies we need to speak to. And one of the principles we are applying here is that we want to be fully inclusive of the wide ecosystem this particular opportunity presents us. So we're going to talk to a number of verticals, including utilities, as I mentioned earlier. We may end up talking to a utility group that represents the utility companies as opposed to every utility company. We'll be speaking to, similarly, we'll be speaking to public safety concerns, healthcare concerns, and at the same time also ensure that we're looking and exploring solutions that some of the ecosystem participants have themselves come up with. So, for example, whether it's Motorola, Qualcomm, Samsung, and others who've also embarked on similar types of platforms for their particular product sets. So we feel like we have to spread a net wide. It is a pretty broad topic, as you can imagine. Lots of verticals to talk to, and creating a single platform is not any small challenge. So we do plan to speak to a number of these companies. Second, obviously conduct these interviews, and that's going to take a long time. just scheduling, summertime, all are going to present ourselves some challenges, but we plan to conduct these over the next 2-3 months. We will focus on some very specific use cases. So instead of boiling the ocean, we'll look at perhaps the utility sector, public safety, and perhaps telematics or something around machine-to-machine, and see if we can nail these 2 segments down as opposed to everything else. And then one thing that it didn't come out in the PowerPoint slide here, but the idea here is that present this in some sort of forum, whether it's a conference, FCC sponsors and supports, or one of the industry conferences. So we will hopefully distill all of our findings, the data we have gathered through all the interviews we conducted, and present those findings and perhaps early initial recommendations to the broader group. We plan to do that in the form of a conference, and we may end up doing 1 or 2 conferences, so we have enough exposure to what we're looking at. Again, supporting a principle of making sure we're reaching out to all the constituents. And then finally, consolidate all of our feedbacks, including the findings from the conference, into some sort of an interim update to the FCC, and then hopefully have some very specific, tangible, actionable items coming out of that as our final recommendation. So that's sort of the game plan. We're very excited with this group. There's lots of opportunities, and we're hoping that we have some very tangible outcomes at the end of this. I think I'm going to stop here and take some questions. I think we covered a lot of this earlier, so I'll just pause here for some questions.
All right, do we have Paul is up first?
Your peripheral vision is improving.
I'm watching.
Paul, you're part of our group.
I am.
Therefore, he's going to have even more difficult questions.
Forewarning, the question comes back, right? You have a sense, Ahmed, Shabbat, about what is significant quantities? How big does the ecosystem need to be considered COTS?
That's a great question. Our early and initial exposure to COTS platform for some of these verticals suggests that a lot of these verticals themselves have a quote-unquote COTS platform.
Yeah.
So take smart grid in the utility sector. They're embarking in a couple of paths. One, to build their own private wireless network infrastructure, or the second path is to rely on a service provider such as AT&T or Verizon here, at least in the U.S. But they have, at least from a back-end perspective, a single platform that they've harmonized and kind of come through now. On the communication side, they still have those 2 variants I just spoke about. And similarly, we've seen this across other verticals. Obviously, public safety, we all kind of know where things are with FirstNet and so on, but I think there's still some opportunities within the security sector, whether it's Homeland or Customs. I think there's still some opportunities for a single platform there. I don't know if that was your...
It is. I think the other thing is it can be recursive. If you stick with public safety, which I know well, I mean, you may look at a public safety device as certainly orders of magnitude lower quantities than commercial. So you may say, well, but if you look inside, it may leverage platform content that the same commercial devices leverage. So some of it depends upon, what you call a platform too.
That's correct.
So it's an early thing. So
that's right. I know, and as you know, well aware, in Europe, everyone's kind of harmonized over Tetra, right. And now they're all kind of figuring out what to do after Tetra, right? I know you've got some solutions there, but I think increasingly what we're hearing is LTE sort of the de facto standard there.
Yeah, thanks.
Milo.
One of the things we
looked at in the PCAST effort was the advantages of actually having DoD and others have commercial users in their bands, because that would drive volume to adapt commercial parts. And this is a huge issue because of the esoteric systems that tend to be deployed there today. By doing this, right, you'll get a lot of potential cost reductions and the ability to have highly integrated devices like this, which just aren't possible with discretes. So I think there's a very synergistic effort here. I was talking to somebody at the DoD the other day, and I said, right now you're in a situation where you're behind, and you are permanently behind. It's like the rapture has occurred, and you've been left behind. And the only way you're going to change that is if you've got commercial devices operating in your band so that you can get these kind of capabilities being moved in there. So I think there's a lot of synergy there. One other thing to think about is there's also the assumption that people have oftentimes, if you're using a carrier protocol like LTE, you have to use carriers to administer it. And that's not really true. You can run your own signaling and control plane just for enterprise use and not link it to the rest of the system if you want to, and still get a bunch of the ecosystem advantages on the CPE side. I think we need to do some work in how we scale or make low-cost core and control HLR, all the rest of that stuff available. But I think there are areas where technologies like that could be very useful if you decouple the technology from the typical carrier management the way it works today.
No, you're absolutely right. I think there has to be a commercial angle, not only from economies of scale perspective, but the whole supply chain, right? Yeah. And we talked about chipsets in the UHF band. I mean, unless you have something commercially there, right? I mean, you're just not going to get the volumes and the commitment from the equipment providers to produce and manufacture those. So I agree with that point.
Kevin. Yeah, as a member of this subcommittee, one of my concerns that we need to make sure we do in the committee, and I just thought I'd pop it out for other people's consideration, is a lot of times when you talk COTS, in fact, just this discussion here tends to be what I'd call narrowly economic. Narrowly economic discussion, and well, I can do this cheaper, or I can get advantage of ecosystem, and that's all obviously very important. But to some extent, it also takes care of itself if you create the right environment, because it's a cheaper way to do something, and most people eventually figure out that it's more important to do things in a more efficient manner than their ego would allow them to keep their own system. But what I do think we have to capture for the sake of the FCC are the things that may not be captured in terms of advantages to some of these kinds of COTS solutions that really are more positive externalities, things that don't actually accrue to any individual who's making a choice, but which may in fact be societal benefits if the FCC could steer in the right directions. And I think there are a lot of examples of this. My easiest example of this, which I've used to the committee, is if somebody like, say, the National Park Service decided that they wanted to use LTE to cover the boonies, for their purposes. If they did that in the right way, yeah, they might save money because they put up a private network, but suddenly anybody with a regular handset might be able to make a 911 call in places where no carrier in his right mind would ever put coverage. That's not an economic benefit, right? No one is going to look at that and say that saved me money, and yet societally, obviously that's a benefit. And I think those are particularly the kind of benefits where the FCC may be the only or one of the few entities that can kind of say, hey, look, this is something we ought to be trying to encourage, because beyond the narrow economic benefit of making COTS choices, there are these other advantages. And I think there are quite a few of those, whether it's military or it's governmental, civilian governmental applications or utilities, where the integrative factor that we've seen, in spades in the internet, where you have a single platform and suddenly externalities and advantages came about that no one would have ever predicted. Those kinds of things could be advantages here as well if you get the right ecosystem. And those are things where I think the FCC can actually have a very positive effect over and above the obvious economic benefits of making a volume choice in COTS.
Dale.
I would just add
I would just add my usual thing. If we're talking about advantages, then I think probably they need to talk about the disadvantages too. And having a single, here again, I've said it so many times, a single technology may sort of slow up technological developments that are wildly different. And the other thing is that if you're going to worry about things like jamming and stuff like that, setting up a system that one person can figure out how to jam, then they can suddenly jam an awful lot of other critical infrastructure too. So I think we probably, in fairness, need to meet both the advantages of having a single infrastructure and then what the vulnerabilities are when you do
point.
so.
Ramani.
So being new to this group, let me ask a question which you might have already answered in the past. Apologies. So I'm trying to understand the intersection of standards and work done here. Talks about cars driven mainly by volume. People are not going to invest money in the building volume unless the standards are stabilized and everything. That may be a necessary condition, but not sufficient condition, because they also have to find out the ecosystem. My understanding is that we assume that the standard work is done, it is there. Now, how do we create an environment that it'll be really, big time use, multitude of applications and users? That's my understanding. Is that kind of a clarification question?
Yeah, no, that's absolutely right. We're definitely not going to be creating new standards or proposing new standards. I think the correct view would be to leverage existing standards that have been well established and finding some common threads between them that these verticals could use. Like I said earlier, when you examine each vertical by themselves, they have sort of landed in some specific common platforms by themselves. And then when you start looking at other verticals, there appears to be some very common building blocks across them. Now, these verticals are some very complex and large ecosystems by themselves, but they're not talking to one another. And so it's very difficult for them to even recognize that there are some common things between them. And so those are the opportunities we're going to explore and see if we can bring these verticals together. And perhaps if not, just even within the specific vertical, try to bring the specific those subgroups together and see if they can leverage each other's capabilities in a single platform basis.
Dale, back to you. Oh, you're not? Okay. Julie.
Well, you had a part here anyway. So, one of the roots of the problem here is we've gone from kind of this command and control approach through the years of I've got this particular application, and so I'm going to allocate spectrum for that particular application and build devices just for that. And we don't really have the luxury today when somebody comes in of saying, well, I've got this particular application and I need 10 megahertz for it. When we look and we see that there's technologies and systems and commercial service providers out there that could meet the same need and potentially more efficiently, and I think, as Kevin says, can work out better for everybody. So I think part of this is it's not just a technical problem too. It's how do you move the mindset from I've got to build my own dedicated system to using to at least thinking about, and seeing some inroads on that front, about, well, how can we leverage what's already out there and build upon the networks that are there rather than trying to build something new.
Right. Good. Henning.
So Julie's never comments, maybe, and Frederica Milo's comment earlier, I wonder if it would be helpful in the communication space. We tend to divide things into layers when we have them in the classical network layer 1, 2, 3 type of things. And one of the messages that I've heard is we tend to think of reuse of commercial kind of off-the-shelf systems largely, at least in our space, layer 3 and above. In a sense, you use a complete LTE system, including IMS, including applications, including with authentication and all of that. But maybe one other way of looking at that you get some of the benefits of a commercial reuse by just reusing, let's say, layer 1 or layer 2 of the one, and even if you build your own complete one, and that might actually address to some extent also Dale's concern. It is a separate system, but you can't just log into with your LTE smartphone on that, but you now have a way of sharing, to address Julie's comment, to do temporal sharing because you have the same MAC layer as opposed to doing sensing or other much more difficult and often less efficient mechanism. So I wonder if the group has thought more systematically looking at a more layered approach to commercial reuse and see what the trade-offs are among like a physical layer only versus a complete system we use.
No, I first thank you for that feedback. We haven't looked at that OSI framework, and I think that's a good way to kind of carve out, exactly where the common platforms are. So I think that's a good suggestion. So we'll definitely take that into account. I would say, though, as you move up the layer, and I didn't think I would ever talk about OSI layers again, but if you move up the stack, we have found that in some of these verticals that the commonality the propensity to share starts to increase quite a bit as you go up the stack. Down below, there's very little, as you can imagine. If you take, again, the smart grid example, or smart metering example, they have their own networks, right? Private networks, and although we are seeing them shift towards more public, but they tend to have their own MAC layer, if you will, of layer 1. But as you go up, they're sharing, whether it's an MPLS infrastructure or maybe a cloud application in the back end that's being shared among several different companies.
Yeah, you're seeing, I think, two separate things. You're seeing the classical hourglass model of the Internet Protocol stack, where you do have this narrow waist VIP layer that has essentially found itself at least to be reasonably versatile, whether this is utilities or whether this is video delivery, which otherwise have very little in common both below and above in that. But I think for our purposes, in terms particularly from a spectrum perspective, I would imagine that you'll probably find opportunities throughout the stack, simply because of chipset reuse, modulation type of issues, as well as layer efficient sharing of resources, and so on. So that you actually raise a good point that there have been traditionally kind of the whole evolution of the Internet ecosystem was all based on discovery of this common narrow waist and associated protocols like DNS, DHCP, and the management layer around that. We now have another opportunity on top of that.
Yeah, that's right.
Dale?
And I would only add, though, that some of that depended upon some commitment to openness and so forth. And so I don't want to turn this into a policy argument, but if there's any market power laying around here, that you may not get the degree of openness that you need to do the sort of thing that Henning's pointing to.
Great.
I was going to hold this off till the end, but I think I'm going to pile on at this point. I always think in terms of matrices anyway, and this seems like it lends itself to an extreme to that way of thinking, looking at applications. What are the potentials, and then what areas? Because we've tended to talk about this as use the whole thing, but where can the commonalities occur?
Yep.
Versus what are the applications, and even getting into some of Julie's points of what are the impediments, if you wanted to add a Z dimension into this matrix. What are the if there is not sharing today, what might enable that sharing to take place? What are the inertial barriers that need to be overcome.
That's right. That's right. And then it could depend on what layer you're at.
Yes,
right?
exactly. Yeah, yeah. And so it isn't because we do tend to think about this as one size fits all.
Right.
You've got to use the whole, in our world,
End-to-end,
tends to be
right.
end-to-end cellular network. We're going to put an application right at the top and have
That's
it
right.
work just fine. But I think multiple people have hit this point now that unlayering this and then looking at it in that kind of construction, I think it could be extremely valuable.
Yeah,
if the
no,
group's
it's
not
great
already doing
suggestion
so.
there.
Yeah.
Just a quick follow-up on that is, if you want to have lots of fun in your committee, of the fun or quotation mark variety, look at FirstNet. And this has really been where I think the original motivation was, and I suspect most of us would consider that a very well-motivated one, was to reuse this commercial off-the-shelf one. But they also ran into some of the difficulties that are instructive. Security is always mentioned, but also that each one of those had a niche application. What in the FirstNet case, the buzzword you usually hear is mission-critical voice. That are of no commercial interest, generally speaking. They're strictly public safety use, at least today. That may change, because it's just not available today.
Mm-hmm.
Where there was the fear because you had to buy the whole package, and you bought the LTE commercial package, that you would still not be able to get your mission-critical voice, for example, in that package, and now you would have you got something, but it was not quite what you needed, and since you now left the systems that you could design 100%, you were left with a system that was 80%, but you had no good way to getting to 100. So that might be one good and really, and because public safety uses a fair amount of legacy spectrum as well as legacy applications that are not very spectrally efficient, often analog in some cases still, or barely digital, but they struggled with some of us once they started going into the checklist of wish items.
Yep. No, just to close that out, we are definitely going to speak to FirstNet and have some fun with them.
All right. Any questions from those on the phone, or comments or suggestions? I have a quiet bunch on the phone today. And Shahid, you didn't want to cover the other slides. You did have more in your deck.
I think that's
you were
the
going to
end.
stop there, right? All right. Let's move on then, and I will
Adam.
swip. Oh, okay. Sorry, Adam.
When you look at sort of the range of applications, I understand sort of the thrust of being able to use stuff over and over again. Have you come across any applications, might even prompt it with a specific, like real-time applications, for which there is value, in fact, in having a separate network? And how would you sort of classify the uses of what's likely to fall first, okay, and what are the hardest things to do?
Yeah, no, I think to Dale's point, I think we have to explore what are the disadvantages of COTS as well as the reasons you don't want to go COTS in a particular use case. So there are several examples out there, right? I mean, the utility guys would claim, and I don't speak for them, that they want their own network. I mean, that's their first. That's sort of their position. But for whatever reason, that's sort of where their point of view is.
But Shahid, I mean, in some sense, I see a thing like metering, which could go over the top. But if I am actually going to run the switching and control system, okay, with very, very tight requirements, that's a different story.
Yep,
Okay?
I agree.
And so I think it is sort of important to create the language and be able to parse this stuff in some sensible way.
Good question. Yep.
The old yarn, nothing focuses the mind like a lack of options, right?
I think is actually very useful in this case. As Julie said, there's just not, you can't allocate spectrum to dedicated services anymore. There's just not enough of it to go around. And the reason we're in this mess is because we did that for so many years, and now we've got these, vertically integrated stacks that we can't use effectively. So it's painful, but adapting to that world will be better for everybody.
I don't want to play devil's advocate, but let me just bring up that if we all use LTE, the whole world's using LTE, who's going to develop the next big thing after LTE?
I think it's a loaded question, Greg.
We've already got that, but but if you don't give them the 10 megahertz that they're asking for, who knows what we might not have gotten.
I wonder if I could. Can you guys hear me all right?
Yes, go ahead, Marty.
Can you guys hear me all right? Yes, go ahead, Marty. Just so you know that the guys on the phone are paying attention. They first, I have a couple of comments.
Yeah, I think you have a loop going with us. I think you have your internet on or something that's carrying your voice back to you again and again and again.
I'm getting yeah, let me. It's because I'm streaming here and I'm getting. But let me turn this thing off.
Streaming is a minute behind.
All right, is that better? Yeah, it is.
Yes.
First of all, there's a myth that there is such a thing as LTE that is a single standard, and that's certainly not true. I think you'll find that LTE is a highly flexible standard, and that different people using LTE will come up with a very different kind of system. So development is not going to stop, nor is there going to be a single standard that everyone's going to use. Now, the second comment is there are some very distinct reasons having to do with spectral efficiency why mixed systems don't always work well. And I don't think, as an example, that the public safety systems are going to look anything like the public switched network systems after a few years of development. Now, the fact is that having a system that has a lot of one-to-many in contrast with person-to-person calling, when you mix those two, you don't get a great deal of efficiency. So I think it's naive to think that the world is going to evolve into one monstrous shared system. We are going to have multiple systems. They're going to be optimized for applications, and the challenge that we've got is to sort all of that out to get the best combination.
But
comment was raised earlier about how lack of options tends to focus the mind, and in particular with respect to FirstNet, there simply will not be enough financial resources to build a nationwide duplicate network. Even the $7 billion on the optimistic side from the auctions won't cover it. So there's going to have to be sharing with the commercial networks, priority sharing and the like, just to avoid so that the resources can be reserved for things that the commercial networks don't do, coverage areas and so on.
Good. All right. Seeing no cards up and hearing nothing from the phone, I think we'll move on, and I'll do the hat swap to move into the next topic, our spectrum and receiver performance area. And as we get the slides up for that, first I would like to just pause for a moment on the...
I think the app has some blind spots.
Maybe
the clickers here.
I'm actually being given the clicker. I'm the one and only person. This is a great honor, so thank you. But let me pause for a moment to mention the work working group members, and I would be remiss if I did not do so. I already recognize those who are providing leadership to the different activities. But this is a very hard-working group, and I really do appreciate that. And I'd like to, in particular, note that we have 3 FCC liaisons for our group. And you can interpret that as you will. Obviously need more supervision than any other working group, even though we are the smallest working group. But the serious part of that is that we have 3 very hard-working members of the FCC team who are contributing enormously to our working group. So I do want to recognize and acknowledge that team of Matthew Hussey, Bob Pavlik, and Julie as well. So moving into our activities, the mission statement is to make everything better in a couple of fronts, and we've already talked about the appetizer, the interference limits, continuing that forward, but really focusing on efficiency from a spectrum standpoint. The study areas, again, we've talked about the 5 areas already, so I won't dwell on that, rather move into the details of each of those areas. From an interference study standpoint, I've already mentioned the 2 main areas, the actual implementation of the policy that was recommended in the white paper at the end of last year, the interference limits policy. There's an enormous amount left to be done. We're quite happy to get the white paper out last year, but there's an enormous amount left to fill in all of the details, and I think Pierre would be the first to acknowledge that point. We are very much looking forward to all of the feedback that comes from the notice that's out on this, as well as the GAO paper that was published at roughly the same time. So that will be a key focus for us. This area of statistical interference risk analysis, again, I mentioned this already in the appetizer section, is an important one. And I think all of those around this table recognize it. We do a great deal to recognize the worst case, and sometimes the worst case, and sometimes the worst case, and thereby, and in the meeting this morning, Julie actually used the terminology that we're foregoing multi-billion-dollar opportunities by virtue of absolutely belts and suspenders and a rope as well to ensure that the pants remain up. So we really do need to make sure that we have the balance, and especially as our spectral resources become ever more scarce. So that's a major focus for our activities. Before I take you even further into the depths of this, the deliverables that we're focused on are to, in each of these areas, the harm claims threshold implementation in a specific band, which we've still not identified yet, but we're homing in on bands to focus on, and then reviewing our current use of statistical techniques, which we spent a fair amount of time on this morning, and really quite a lot more than we thought, at least than I thought, within the FCC context already. But at the same time, the statistical techniques are relatively limited in scope that have been applied in the rulemakings that we have. From the December standpoint, we really are looking to have concrete recommendations, and that's the hope that each of the working groups would have concrete recommendations that would have meaningful impact, and that was one of the hallmarks of our last year that Chairman Clyburn recognized us for, and that Chairman Janikowski had earlier recognized the group for. So moving into those areas is going to be really critical. From a context standpoint, already talked about this mostly, but the key topics are the harm thresholds, harm claim thresholds, getting down to the detailed level of that, really understanding it, something that we could use a lot of help from outside, and we're getting some of that from different parties. The use of measurement approaches and modeling approaches, it's really not or, but both of them to determine the thresholds is key, and then providing the recommendations we've talked about. The statistical part, double-clicking on that, is really understanding the risk, that risk equals probability times severity. We're really pretty good at severity, not very good at probability on risk, and therefore we do end up with the context that we've already talked about. We really are looking to dive much deeper into this, and I've largely covered this already. From a multi-stakeholder organizations activity, we're really trying to dig into that to understand more about the successful implementations of multi-stakeholder groups that are out there, and some of those are listed in the second bullet. Some of them we know a lot about, don't we, Dale? With BTAG being an example. This has been a hot area for Dale for some time, and certainly Lynn's providing a lot of leadership on this as well. There are lots of questions about this, though, as it is applied to the interference limits, the white paper that we've already suggested, and so that's what we're moving on. And a lot of those questions are listed here, and I won't walk through them one by one, but we do have a lot of questions, and that's good. There's a target-rich environment for us to work. It's not so good because there are lots of things to be answered to get to where we need to be. Here again, we have a set of deliverables to really get that understanding out and make it available to others, with the end being a recommendation on a governance process that really is appropriate for the interference limits, and then moving forward to hopefully implement that direction. Next, the radio service knowledge base, and we could use help from the TAC on a better name. The name has evolved, and it's gotten larger every time it's evolved. But the scope is also enlarged, and I think that's why the name gets to be broader and broader, because we started again at the receiver end of things, looking at the whole world from a receiver's point of view, and fairly quickly we came to understand that transmitters have a little bit to do with how receivers perform. And Greg is smiling over there because he is the one that really banged on us all to move up to first the system and then the full service level of view of this area. But I think it's going to be invaluable for us to actually come up with a mechanism for capturing this information and making it readily available. An enormous service for the FCC to be able to provide. A non-trivial capability for the FCC to provide as well. And I think well beyond our working group, this is something that the TAC can contribute. Both the ideas of how to pursue this, what needs to be there, where the different materials already exist, be it standards, be it existing services and their use that could be made available. But I think we would be enormously ahead of the game if we can pull this information together and make it available. At minimum, it would remove all of the excuses. Well, gee, I didn't know when I put whatever immediately next to the system and destroyed it. At the other side, and the much more positive side, we are moving into an ever more collaborative, cooperative environment, and the more information that can be shared across the boundaries so that we have good neighbor situations, this can be a significant force for good in that direction. The challenges are numerous in this, and I guess I should start here, but some of the services operate very, very differently in different bands, even though it's the same service. Many bands have numerous standards associated with them, and particularly the unlicensed or lightly licensed areas that are out there. The devices, some do not have industry standards. There's no information is totally proprietary. Certainly there are standards within an entity, but they're not readily available, and finding a compelling reason for people to provide that information is a key aspect of this. And then making sure that we can be proactive in this area and even move the database that exists into a more useful state. And the multiple bullets that lie under this one were worded very carefully about 5 times, because there are things that are lacking in the existing database, and there are those that are quite concerned about that. All of us should be. But at the same time, there's enormous value in the database as it exists today, and moving forward, we would hope to make it more valuable. But as we make it more valuable, we want to overcome some of the issues that exist today, and some of them are structural issues. They're not FCC issues. They're challenges as you as to what you require people to provide in terms of information and who must provide it and how is it captured and effectively kept up to date. So those are challenges for us to understand. We're working on the gap analysis, and hopefully we'll have a lot more information at that next time around, but then get to the place where we really have an in-depth, comprehensive approach to this is where our goal is for the end of the year. Emerging technologies, an exciting area, not unlike the first of our working group topics. A lot of technology advancements are moving out there in all dimensions, and really understanding even the breadth of what all of those areas are is critical, and then to take the deep dive into seeing where these areas are moving and what's ripe for the picking to move forward is a key element for our investigation. The goal here is to come up with a white paper that would describe the emerging technologies and the impact that they may have, and therefore to influence policy that would facilitate those emerging technologies that are becoming ripe to actually be deployed. Some of the emerging technologies that are out there are listed here, but this one that I've mentioned in the appetizer section, the full duplex operation. There are folks out there in university land that have deployed capabilities that operate on a single channel bidirectionally. That's one of the great things that people have been trying to do for years and years and years. There are considerable limitations today as to exactly how and what has to be in place to make those work. But the very fact that there is an existence theorem that some examples have been put in place is a big deal. And we need to be tracking that and figuring out how to accelerate the optimization of that capability, because by itself that gives enormous spectral advantage from an efficiency standpoint. The interference cancellation that is in some cases related to the first point in the how you implement the full duplex operation. But in general, how do you ensure that you are able to cancel out all of the noise, all of the interference that comes from all the other sources to be able to pluck out the signal that you're really trying to gain? And this gets into a lot of the things that are near and dear to Marty Cooper's heart with the beam steering and the various approaches of multi-antenna to be able to take advantage of this. Waveforms themselves, we are ever evolving our waveforms into more exotic cases that have very significant strengths, and taking advantage of those is key as well. Also, ensuring that we have the ability to handle the send and receive capabilities in noisy environments, and that we can understand where we stand from the use of a database to understand the environment and make use of that. We also want to take advantage of devices much like the John Chapin's radio map technology to have group sourcing of the information that's out there so that we can populate those databases and understand our environment. And then it's the whole area of the devices themselves, software-defined radios, cognitive radios as these are evolving, the whole movement in smart front-end amplifiers and mixers and increasing their dynamic range as well so that we can handle the very weak and the very strong signals with the same device, dynamic tunable front ends and all the rest. So producing a white paper in this area is going to be a key deliverable, and we've got lots of white papers and a lot of things going on as you're rapidly seeing. Final area is, again, the area that's Dale is providing leadership on, the interference resolution and enforcement. All very good and fine to have interference limits, to have all of the other policies in place, to have the standards well described, and to have complete understanding of where those all exist. But without an ability to enforce those standards, we really have nothing. And to do that in an efficient way, the day of going around with a truck and checking for problems is long past. So we need to be able to observe things from afar. Sometimes we'll be observing systems through purely computer means, watching the the way things flow. Sometimes one near and dear to my own heart is, in fact, establishing spectrum observatories that are fixed installations that can detect anomalies and can detect changes in the environment. But this whole detect, locate, identify kinds of techniques that have been out there classically have to be rethought and handled in very, very different ways, and I think that's a key part of where we have to move forward to understand how to do that in the modern age. And a lot of work to do that. Crowdsourcing may be part of the answer. The spectrum observatory kinds of things may be part of the answer. But this whole way of being able to understand the environment and detect the anomalies and deal with them, isolate them, identify them, and deal with them is really a key part of this. Some preliminary recommendations we're hoping to have by the next meeting, and then to draft a final report by the end of the year is the goal. So very, very busy path ahead of us in the committee. A lot of very good work. We're also looking for volunteers, both from the TAC and seriously, those that you might recommend that could help in one or more of these areas. That would be greatly appreciated, because we really have chartered out a very large area to cover. So now let me turn it over to the TAC to solicit your inputs. I've just switched hats again. Now I'm... I always love this. This is very different from my classes where I enforce questions. Now Thanks a lot. Yeah. No.
Small teams are agile, Dennis.
Yes. Yeah, we actually discussed that this morning, that one of the real advantages of our team is we didn't have nearly as large a challenge as some of the other teams on communications, because there are so few of us. And we've even divided those down into teams of 1 and 2, so the communications is very, very efficient.
I'll go first.
Okay, Michael.
Yeah. So maybe this is for Dale. On the enforcement side, since we started as a receiver performance working group, any thoughts on what you think you could kind of enforce on the receiver performance perspective? Any thoughts or any suggestions that has come up on the working group discussion?
Not specifically, and that goes a little bit to scope. And one of the things we had, and there was a list of sort of tools that the commission uses now in enforcement, from everything from what that lab does to what the call center does, and so we're trying to take a sort of a very broad look at the different tools, and we have not dug deeply enough into what you're suggesting of how we'd actually enforce against receivers. Did I answer?
Yeah.
Good. Thank you.
We have discussed, and Dale was a big proponent of this, future devices, receivers and transmitters, that keep a log of their activity. Receiver, what it hears, transmitter, what it transmits, makes that available to a common database, and then you just mush it all together and try and figure out who's doing what to whom.
Yeah, that's sort of the black box recorder notion, and I want to make sure that was an idea. I think it's John Darp, I think, is the one who originally proposed that. I think it's sort of an intriguing idea, even if it was done on a sampling basis, to be able to go back and replay the last 3 minutes of which you had a severe interference, and try to figure out what was causing it. Thank you.
Great. Any other questions in the room? All right, turning to the phone. Any questions on the phone?
For that.
All right, hearing none, we'll move forward. And Russ, welcome to the group, and thank you for taking on the challenges of travel in the stormy environment.
Be here. I think the challenge is to come home. I just found out my flight's canceled going home. So I'm here.
Julie's suggestion sounds good. Since no one can travel anywhere anyway, and the rest of you live here, we might as well extend the meeting by a couple of hours.
Yeah.
We've overloaded the system checking.
That's going to be fun. I'm representing the Resiliency Working Group. I don't have the clicker. Do I need that?
We'll just pass it around.
If you could, somebody click it along the way. There we go. That's a good slide.
No, it's done.
All right. So when we started talking about this working group, the picture kind of summarizes, I think, and probably brings different things to different people's minds over the last few years or even the last few weeks. Tornadoes, obviously, in the Midwest. Thank you. There's a fire raging right now. We had our first tropical storm already, and we had an event up in Boston a few weeks back as well, unfortunately. But I think the focus of this group is really looking at, the question of how do we ensure that we're actually getting better at resiliency in the network. And, when we look at this in 5 years from now, 10 years from now, or 15 years from now, how do we know if we've gotten better too? Okay, so we do have the largest working group, I believe.
Yes, you do.
And we only have one FCC liaison.
That was part of the point.
I will make no comments.
Somebody cares.
I think we do have a very good spectrum of members on our working group, by the way. I think we've got, everything from providers to, emergency experts, et cetera, and which is what we really need to address this topic. And by the way, when I was preparing for this slide, I started to think about this in terms of the resiliency and what it means. And it was kind of weird. What came to mind was the old Maslow's hierarchy. And I started to think about where probably telecommunications and broadband have moved over the last 10 years or even 20 years in terms of on that pyramid. And I think for many of us, it's in the food, clothing, and shelter spectrum now. It's not self-actualization anymore. So I think it's become extremely important to all of us, and that's why it's really important in times of either disaster, whether they're man-made or natural, that we address this issue. This slide tries to tackle the premise of what we're working on here. And again, we've had quite a few recent natural disasters that have sort of really brought this to the surface. Some of those were named Katrina and Sandy. But, it really brings this importance of why the network needs to be resilient. And a focus on how to address both that as well as some of the cybersecurity threats that are, I think, just going to escalate over the next few years. By the way, we're going to address in this, in the premise, there's all types of access networks. And by the way, I'm talking about access because we're trying to focus a bit more on the access piece. We're not ignoring the core or the metro, but there is redundancy typically in those portions of the network. We will take a look at that as well, though. There's also, obviously the wireless and trunk radio networks that are out there. And then underlying that are, we call them, it's listed as supporting services, but it's more or less what makes those networks work, the protocols that underlie those networks that we want to take a look at as well. And, the deliverable we're expecting is a white paper and some actionable recommendations. So I'll go into some detail in the next couple slides. Whoops, I'm a little bit behind there. Oh, that did it. Okay, so the proposed scope, the first thing is to define resiliency as it applies to communications networks. Next, we want to focus on the two large buckets. What we see, as I've mentioned, there's the disasters or natural disasters, avoidance, recovery, as well as what we're calling substitution. And substitution brings into play both from a provider perspective as well as from a client perspective. I think when you think about what you have at home today, like the other day I lost power last week, and I called to report the power outage, and the company said, well, go to our website. And I, Well, that was my initial reaction. I thought, well, I still can go to the website.
Yes, right.
But
Yeah.
it was still not the answer I wanted to hear at that moment. But
Your power is out.
yeah, exactly. And I do have a small UPS in the house, but it still does not keep all the equipment working. But substitution has become a very important part of disaster recovery. Then there's the virtual and cyber attack avoidance and recovery. Our plan in this working group is really to work closely with the security working group so that we don't replicate work and that we're in coordination. So we see that more as the security working group's main focus. We're happy to work with them, though, and that's going to come up in some of our actions. Again, we're going to focus on the distribution part of the network. Also, traffic prioritization, a review of what's currently out there, what potentially could be done possibly when there is a disaster to try to address either a shortage of access or congestion in the access network as it applies to voice and data. And then specific issues we want to address on the rural side because it was brought up, there's much bigger issues than just access when you get to the rural piece because if there's a single point of failure in a lot of the interconnect sites, that becomes a bigger problem as well. So. All right, so the first thing I went and did was pull down a definition of resiliency for discussion within the working group. And I thought it was rather interesting because I think everybody probably gets what resiliency means, but the bottom bullet really got my attention because it talks about, it returns to its original shape or position after deformation that does not exceed the elastic limit. And I think we've seen networks in the last few disasters, I think, exceeded the elastic limit. So, and that may be something we need to look at as a working group too. We haven't really talked about yet, but what is that elastic limit in terms of a network? And there are going to be disasters that definitely exceed that. So we need to be cognizant of that. In terms of some of the proposed actions and deliverables, the white paper that we plan to produce, there's quite a few options or quite a few areas that we want to look into, from the definition, building out some of the use cases in the different disaster type scenarios, how to deal with disruption and redundancy in the distribution network. Again, looking at either industry solutions that may move to those where you have substitution available. Also looking at the review of the traffic prioritization and traffic congestion, how to expedite plant repairs in the event of disasters, and even prioritize those. Most of the companies already have a program in place. I'm talking about provider companies. And then taking a look at the protocols, too, that facilitate or may help facilitate better resiliency in networks. And we've got some examples listed there. Also, a proposal to evaluate the impact and survivability in terms of a forecasting. If you do have like a Cat 5 hurricane coming into a city, it would be nice to know how bad your network's going to get hit or how much problems you're going to have. I don't think it's going to be a perfect science, but it would be a good predictor and also help in terms of planning for some of these avoidance, to handle avoidance. Also, the investigation of user diversification in terms of services. Again, we call that substitution, and the rural issues themselves. We will work with the emergency service and public safety in terms of whatever tie-ins there are there in terms of the actions. And then slide 2, there's a section of this in terms of deliverables. On the recommendation side, we want to focus on market-driven collaboration. I think everybody in the team agrees that's probably the best way to move forward. There are practices in place. There are plans in place. I think part of it is getting some of the data out there and maybe a little better collaboration. How to improve speed of recovery and response time. There's what I call collateral outages as well that also often impact restoration efforts. And I talked about the power outage in my neighborhood a couple weeks ago, but obviously that's going to affect the ability to restore a lot of broadband networks. They do require power. There could be, whether it's gas lines or whatever, and there's quite a few different issues that can impact the restoration of resiliency. And then the other piece that was brought up was government reporting, and there were a couple jokes made, but all joking aside, I think it's very important in terms of how we look at the reporting piece. That there's another piece that we haven't addressed here. How do we get the information to consumers as well? Because a lot of times consumers are left stranded in the dark. And it's not intentional, it's just, well, okay, literally. But, yeah, it's not intentional, but, you know, they don't have access, they don't have connectivity, but how do you get that information out to people or let them know of other substitution opportunities? The other thing we want to look at are incentives in either government programs or government assisted program for temporary restoration of services, whether that's a CO in a box or a data center in a box, whatever you want to call it, or ad hoc cell tower, or Google Fiber to the home on wheels.
On wheels.
So, there's a lot of things we could explore. Yeah, fiber to the pole. Yes. Also, I think it's really critical, though, that we look at the measurements and metrics, because the real question up front was, how do we ensure that the network resiliency is better in 5 years, 10 years, or 15 years? And there has to be some way to measure that and metric it moving forward. So, and there's a couple of topics there, the mean time to failure measurements, mean time to restoration. And there's some existing data, according to Henning, that we may be able to leverage. There may be some sensitivity there, but we'll try to take a look at what that existing data points to. Okay, so next steps for our working group. We will probably form subgroups. We are the largest team, so we'll probably divide and conquer in terms of some of the efforts. And we'll have a liaison with the FCC on the existing resiliency data. Create a liaison with the security team in terms of how we divide up the cybersecurity restoration and resiliency. We'll have regular subgroup meetings, regular all-hand meetings. Start the white paper immediately. That's already, we're working on an outline. September TAC, we hope to present a draft white paper and some draft recommendations, and then in December, present the formal white paper with actionable recommendations. And that's where we stand today. So very open to questions, comments, or input.
Mark.
So we talk about resiliency, and it strikes me that in sort of internet cloud world, we've gone through this progression of first talking about making things robust, but then we find that they're brittle and they break. So we talked about resiliency, and increasingly people are now talking about anti-fragility and thinking about how to build systems that, in fact, it's sort of analogous to your dictionary definition. The elastic limit increases because you're exercising them continually close to the elastic limit. Yep. Is that something you've been thinking about as we think about resiliency in this context?
Yeah, so if I could maybe reframe the question, the way I understand it is, telecommunications and communications have become much more complex. And I think we've also pushed, as the providers and vendors, et cetera, push for higher and higher efficiency and optimization. So yes, if that's at least that's my takeaway from your question. I think it does make it a bit more difficult because there's less wiggle room in terms of spare availability. Where, for instance, from an industry perspective, if I'm provider A and my network goes down, having some type of an agreement with provider B may not really help because their network's already at 90% capacity. So it does create a bit of a complex, how do you do that substitution? How do you, in terms of if you want to back each other up or something, if that was even an opportunity. So I do think it creates a great deal of difficulty. The other piece is, we have talked about is there's so many different segments of the market now, or of the network, so to speak. And network's probably not far enough reaching because you've got, we talked about the access network, but then you have all the apps that you talked about that are in the cloud. You could have a failure at any one place now in 15 parts of the network. They're all different companies involved in those. So it does become much more complex because there's so many more players and so many lines, or so to speak, handoffs. It's a good point, though, and it's one where we will have to address, I think.
Awesome topic, by the way, because I do think it's something that we don't spend enough time on as an industry talking about.
You're welcome to join our group.
It looks like you have plenty of help. I think the first part, though, is really your definition is critical. What's the goal? when we say resiliency, and you said in your comments, we know it needs to get better, we should push really hard to understand what is better. How do we perform today? Why is it? It's an interesting jump to, well, it's access and metro and core networks, they seem to be pretty good. I think intuitively that makes sense, but there should be some more specific engineering way of saying, in fact, that is the case, because I'm not sure it devolves exactly to that, to your point around rural connectivity versus more urban connectivity. So that'd be one thing. The second is around, when you think about resiliency, I always ask our folks to think about it. Well, do you mean the next second? Do you mean the next minute, hour, day, week, month? What you can define resiliency with a temporal component to it. And when you think about these big disasters, they tend to make us think about in days, weeks, months, and then you ask yourself, well, what's the implication then? And one of the biggest ones that I think we don't address enough is the supply chain. So if, in fact, you need a roll-up Milo house, how do you do that? If there's a flood in Thailand that destroys the whole disk drive industry for 6 months, what do you do? And I think that level of understanding resiliency in the supply chain is critical as you think through the work.
I appreciate the comments. I think they're great comments, and I agree on the definition and the scope in terms of saying, let's make it better. Let's figure out what it is today so that we can either set metrics or at least gather data over the next few years and decide whether it's become better. On the supply chain, it's an excellent point. I think every company's really become efficient at the supply chain management, which is a nice way of saying, again, there's no slop built in. So you see this happen even in building materials whenever there's a major disaster or hurricane. It's like the price of plywood will go from $7 a sheet to $35. And that's kind of like, well, the supply and demand chain, but it doesn't help those who need the plywood either. But the same with broadband or telecommunications.
Sure. We'll just work our way around.
So I agree with Jack. I mean, I think the question is on resiliency and what is it? And if I could just say that we work a lot with John Healy at the FCC, to do our DERS reporting and also other outage reporting. And one of the things that comes to my mind, whether it be Sandy or whether it be, some Irene or whatever, is power is absolutely super critical, And at the end of the day, most of the service providers are actually building a highly resilient network at that, that point within their network, even in the access network down to, the node, et cetera. And so, and we put in systems that basically provide power backup, whether it be, UPS and generators. In some cases, you have alternate fuel capabilities at those locations. But, power is such a critical issue. And again, if we define resiliency as to the end point of the big network, aka a node that serves 600 or 700 homes, as compared to a network that goes down all the way to the house. Because at the end of the day, if you take Sandy and you take my company, most of the impact was associated with the power to the homes, not the power in the network, et cetera. So I think that's important. I think looking at some of in a way that the FCC allows you to, looking at some of the information to say how much of the issue really is associated with power, how much of it is associated with, supply chain, how much of it is associated with other items, because they do tracking of that information. The interesting thing about the supply chain, too, is that it doesn't necessarily affect you the worst when you're going through the disaster. And I love the Thailand example because probably everybody at this table saw disk drives failing not at go down, right? they saw it, 2, 3, 4, 6 months afterwards, and, it had major impacts. So, I mean, I think, that becomes important. But I'd say, Russ, it might be really interesting to have maybe one of the subgroups talking to, John Healy and his team and some of the other areas in the FCC that deal with reporting, whether it be business services reporting or whether it be disaster reporting.
No, I'm taking notes, so we'll definitely follow up on that. I think it's a good point.
Mm-hmm.
You're welcome to join our team, too.
More than happy to.
Yeah, I know you have the biggest
Soon
team.
We're going to be the TAC.
But she doesn't work for the FCC.
Okay.
Yeah. Russ is taking over the world, at least the world of TAC. Pierre, continue.
Speaking as somebody from one of the smallest teams, speaking to the biggest team, one of the things this is a very interesting project, and I'm very interested in things that the interference studies work group can maybe take from what you're doing. Because if you look at the interference limit stuff that we did last year, it was essentially saying to receiver systems, here's the environment you have to be able to deal with before you can complain, but you figure out how. So that's a very trivial resilience requirement.
Yep.
So I'd be very interested, what your group comes up with or thoughts you have now. To what extent should the FCC have requirements on resilience? And if it does, how does it frame them? Because we could use that kind of information too.
Yeah, so we've had some discussions, and I think the term requirements we always try to, put till, after we do some of the work in discussion, because we're more of our charter we feel is we should focus on the technical pieces, present what we can, and then the FCC can decide what they want to do in terms of if they want to have other additional requirements. The goal, again, was, I think you have very good points, but the goal for our team is to look at industry collaboration first. So before we get to the term requirements, but again, I think you've got some great, there's an opportunity to work with your team too on the interference piece. So hopefully that answers your question.
So a great project again. I echo everyone's sentiments here. You brought up reporting. It would be interesting to see how we fare in terms of resiliency. First, defining it and what the equation is and what the metric is would be useful. But then also looking at how we fare amongst other peer countries. I think, as you know, there's a famous metric out there on power, and I think U.S. is actually doesn't fare very well in terms of its outages compared to some of the Western European countries. But it would be useful to have that benchmark and see, I don't know if there's an apples to apples comparison, but it would be useful to see that.
Yeah, we've actually had a short discussion on the comparison with other countries, and I think it would be a great thing to do. I would recommend when we do that comparison, we also have to consider private companies versus maybe more
state utility.
Yeah, because there's obviously different models across different countries in terms of how infrastructure and so forth are managed and paid for and et cetera. So we've gotten down into some interesting discussions on everything from talking about after a disaster even, do you need to replace like for like, or can you do upgrades? How is that treated? So there are some regulations we need to explore as well, but I like the idea of the comparison with other countries.
Maybe a philosophical question, I don't know. Is the scope resiliency of a network, or is the scope resiliency of the communication from an end user? The reason I ask is you mentioned multipath. I don't think you really meant multi-networking, but that's an answer for an end user. Second thing is, in public safety world, we design the system so that it's resilient to a certain degree, even if the network does fail. Individuals can communicate with each other. So just a question of how, what the scope really is here.
Yes, so the scope in our view is really, I think, more focused on the bigger network. And now, of course, how that impacts the end user is sort of like part of that scope or under that umbrella as well. So, I think we have to look at it. There's two pieces as we talked about. There's that substitution from the user side, and we talked about power's an issue as well. When you have a major outage, if you still have a cell phone and a tower is still standing, you kind of have a charging system in your car. I mean, your car is a charging system if you have gas. But we're more focused on the network side, at least at this point in time in the scope, is how we've talked about it. But really how it impacts the end user is a critical piece of it all. But I understand the resiliency built into different products and so forth. And the reason why we kind of picked the access, that has less resiliency built into most products than any other. So, and I don't say that, it's a generalized statement. I don't mean it, certain products have more resiliency or redundancy built in, but most access networks, you do not have any type of redundancy. And if you cut the cable, you pretty much cut that whole neighborhood off, or however it goes.
Jeff?
Yeah, it's kind of a follow-up to Paul's question on if the resiliency extends to the end user. I'm going back to the days of, Conelrad radio. The radio station has a backup generator. They got a redundant site, or the TV station. You got a portable radio. And so now, you take this scenario where you have, the consumer may have a battery-powered device like a cell phone, smartphone, something like that. But how far back into the network does this AC power redundancy or UPS requirement extend? It seems like that's a big problem down to the neighborhood, not only the cell site, but if somebody's depending upon DSL or DOCSIS connectivity or FiOS or whatever, all those amplifiers and systems at the neighborhood level are AC power dependent, right? So what's the intention in terms of how far back does that redundancy or that power backup have to go, and what, if any, responsibilities does the end user have? Because if the end user doesn't have a UPS or something to keep their router up, they're not going to have any connectivity as well. So, I don't know if that's in the scope of what you're talking about or not, but if you're looking to the end user beyond a battery device, powered device like a smartphone, if you're looking at any other connectivity issue, there's going to be issues all the way back into the premises.
Yeah, I think it's a good question. And again, you made a word swap there, sort of. I think we want to focus more on the resiliency, not the redundancy.
Okay.
And because you used the word redundancy a few times, and to me, redundancy.
I meant resiliency. Yeah. I meant. Okay. Does it operate after an event?
Right.
Right.
Okay. Because the team's really going to focus on the resiliency piece, which could include practices and procedures of how to go out and get that power in place. It may not be redundant, but the service provider has an action plan to go out and get that fixed fairly quickly. Or there's another opportunity to do substitution with different technologies if you lose your main feed. Again, and when you talk about powering in the network, it was pointed out that a lot of the providers do have generators either on wheels or at sites. And I'm very familiar with a lot of them just in my neighborhood that have these big diesel generators sitting on them. But it's one of the things we will look at in the team.
That also brings up the question of whether your group is going to do any investigation of how long does a typical outage last. Some of them can be for a long time, but on average, statistically, what kinds of systems could be required? Would it need to be kept up for an hour or 2 hours or a day, or statistically, what's the where most of the events occur in terms of timelines?
And I do think that there's practices and procedures. Again, I used to work for one of the providers, and I remember there were like 8-hour battery backup that was required at some of the CEV sites and remote sites, and then the COs have they probably have different things than lead acid batteries today. Maybe some of them still have the lead acid battery backup systems and generators. But as you get further back into the network, like at the central office, there is that capability for, I think, self-sustainable power generation. I think it's as you move out into the network, because you have gotten you push technology further out into the network now. And a lot of people don't have that minus 48 powered phone, volt phone at the home anymore that's powered from the central office. It's either a VoIP connection of some sort or maybe just a cell phone even. So.
Dale.
I just had a quick question on scope, picking up a little bit on what Pierre said, but you talk in terms of man-made disasters. Are you going to look a little bit at intentional interference issues that sort of relates to what we're doing too? And I was just sort of curious, was that part of to look at deliberate interference where there's disruption is man-made, but and deliberate jamming would be obviously
Yeah, I was a little worried you were going to talk about the NSA. But
no.
Yeah, we will look at some of those issues as well.
Yeah.
Henning, this is the ringer question. Henning being the FCC member or liaison.
No,
to this
actually, I
group.
wanted to pick up on something which was mentioned earlier on the other working group, on the COTS working group, where one of the questions that I wonder about in terms of reliability is one of the arguments that we've often heard, FirstNet is a good example of that, is why they cannot use commercial off-the-shelf systems, not so much technology, but primarily systems, is because it just isn't resilient enough. And so that might well also be, and you mentioned the quantification of that, is, either you can dispel that, or in particularly as users want to move towards commercial systems, we may well find ourselves that new users, such as public safety, utilities, and others that have higher reliability requirements, may well drive improvements in systems that were seen as consumer systems largely, where presumably there was less emphasis on mission-critical reliability type of thing. So I'd be curious from the the COTS group, if in their investigation, if they can also help quantify what some of these requirements might be in a more, beyond just simply saying 5 nines, but something that is a little more precise, because that might also help drive a little bit in terms of a customer requirement, if you like, if we want to move to those type of COTS system and shared infrastructure.
That would be good.
So it wasn't the ringer question for you, Russ. Rather, it was the ringer question back to Shahid.
Yeah.
Very good.
Pass it back on to you. No, it goes back to your layered framework, right? And what are the opportunities in each one of those? And this one could be, the most fundamental layer of power, and it could be shared absolutely.
Any questions online?
Yes. Any questions out there in the hidden world?
Yes.
Good, Naomi.
Yes. I'll try. Can you hear me, Russ?
Yep.
Dennis?
Yep.
You can. I just wanted to comment that, Russ, you made a comment before about replacement. I thought that was very interesting, and I wondered if that should be one of the things we kind of study is, what does that mean to resiliency. I thought that was interesting. That was one comment. And then the other comment I just wanted to mention was just about resiliency, and you were talking quite a bit about a number of things, such as some of the innovation that's happening with power. I know not only do we have a lot of, you mentioned generator power, but not only do we have a lot of really ready standby power, not just generator power on wheels, but a lot of standby power, but we also do. Most service providers now do a tremendous amount of standby power monitoring as well, and power supply monitoring as well as standby power supply monitoring. So things have, I would say, the investments are bold now in our ever competitive world. I wondered if there's a role to play to look at ways that we can reward and incent really innovative investments in resiliency, because I actually think that there is so much innovation in this area now. So I wondered if that's something the group could discuss as well.
I think it's a great topic, and it's good feedback, Naomi. I like the idea on the power side too. I think all of us have been waiting for either better battery storage capabilities, different fuel cell types, things like that. So it would be an interesting area to look at in terms of at least that perspective, as well as I work in a vendor company, so. Our incentive is usually customer satisfaction, but I do think that, that'll be driven through customers, either demanding certain types of capabilities and products, or or regulations even. So.
Any other questions from the phone line?
Thanks for the input, Nomi.
Okay, Ramani.
So this is more a comment that in terms of traditional traffic management, usually there are two strategies. One is the so-called protective controls and then the expansive controls. And I'm glad that that's kind of a very similar concept. We are using the protective controls map into avoidance situation. How do you prevent certain things occurring? And the second concept of expansive controls, if that has happened, how do you find additional resources to manage the existing transactions? So that maps well into your avoidance and substitution, I think. So that's the comment I wanted to pass.
So is that a comment more on traffic management and network management?
I was saying the parallels between the management of traffic and the particular study that's working group activity of on the access side of resiliency. I was trying to map these two. It seems to be right along the same lines. I wanted to comment that I agree with that approach.
Okay. Thanks for the input.
Good. Last shot at Russ. Oh, very good.
Or a team member.
Exactly. So this is to maybe get more people to volunteer. And it's basically handing after I listened to the end where we sort of contrasting consumer networks and critical networks that maybe aren't consumer networks. And I think about even as Earthlink thinks about distributed NOCs, and our business recovery plan might be something like if the NOC goes down or a NOC goes down, which is a critical infrastructure, and you do a lot of protection around networks and power around a NOC, the backup plan is for people to fire up the management apps from home. And so now, really, what was originally designed to be a consumer voice network is now a mission-critical data network. And so I think as we think through sort of the resiliency requirements, we'll have to think through kind of what happens when mission-critical people are working from what was historically designed to be a consumer voice network.
I think it's a really good point, because I think the consumer voice network has morphed into it's a much more complicated and much more capable network.
Yes.
In terms of both expectations and requirements, which also adds a decent amount to what is required to be resilient. So, to get back to one of the first questions over here.
Okay, very good. I think we have concluded. We'll take Russ off the spot. Special kudos.
I've got all day.
Yeah, and night. For
I'm not going anywhere.
No airplane. But I did want to have a special shout out to Russ, because he did pick up the chairmanship of this the largest of the groups a little later than some, and really
Thanks.
Appreciate your taking
no
that
problem.
lead, running with it.
That
brings us to Paul Steinberg and the Communications Infrastructure Security Group.
I stand between you and going and sitting at the airport, hoping and praying for a flight. Well, except for Russ, who's already has his fate cast. I'll try to be brief. So just a quick shout out. I'd asked Adam to sort of act in the role of vice chair. Between the two of us, we've been able to get the group together most of the time. Special appreciation to Greg and Ahmed, our FCC liaisons, and we have, I think, the right number. It seems like 2 seems to be the expected number, and they've done a great job for us. So, mission statement. The key points here, obviously, a lot to read, but the main thing, I mentioned it earlier. They quickly scoped us in from communication security or infrastructure security to cloud security or cloud infrastructure security. So that was a specific narrowing up that actually helped us quite a bit to start to get our head around it. The mission, the key objectives are following along the similar path that a lot of these work groups typically proceed down. What are some of the key issues and concerns? Are there any quick wins that we can identify? what's the landscape look like out there already from the perspective of computing standards, other activities? How might the FCC and industry or these groups collaborate? Ultimately, what are the gaps that make sense to home in on? And then finally, the ultimate recommendations. You see on the right, it's a fairly large group. It's not quite as large as Russ's annex of the entire TAC, but it's a very good-sized group that's working very, very well.
You are the second largest.
We are the second largest. Okay, good. That's good to know. Keep it that way. I see a competition in my future here. See what kind of enticement we can come up with. So what we've done so far, I mean, this is the nutshell summary. We spent a lot of time really trying to get our head around the scope, because while the scope was a significant narrowing, it's still a very broad area, as I mentioned earlier. So we spent some time around scope, getting a lay of the landscape, and kind of squaring up on the vernacular, because there's a lot of terminology here that is still kind of evolving and isn't completely consistent across the world. We pulled in the Cloud Security Alliance as a very logical representative group, and they helped us quite a bit, and I'll come back to that in a little bit later slide. We constructed 3 subgroups. First group is the largest of the subgroups by far, focused around consumer and enterprise. And that kind of leads us naturally to public and hybrid cloud topologies as well. Joe Wetzel is agreed to be the leader of that. Thank you, Joe. Second group was around critical infrastructure, and that kind of honed us a little more toward private cloud, not an exact mapping in any of these cases. And George Popovich from Motorola is actually leading that, along with Adam and I. And then finally, network access kind of cuts across both of these groups, because obviously the cloud is only as secure and accessible and reliable as your ability to access it. So Harold Tietz, who I believe is on the phone, has graciously agreed to lead that group. The other thing that happened along the way, and it's shout out to Donald Tai and David Tenenhouse, Donald from Verizon and David from Microsoft. We didn't call it a work group, but they took the undertaking to go off and categorize and catalog all of the different initial pass at the landscape of what this world looks like. And you'll see in a couple of slides that there is a fairly large bit of that out there. Next slide is kind of 2 things in one. If you look on the left side, you'll see that it's kind of the way we started to think about it, and it was actually kind of a 3-dimensional diagram. And it's kind of what we got our head around, and you see that it's kind of what I've talked through already. The group 1 is around the consumer and the enterprise, and that, if you look at the far left, that kind of leads us along the public and the hybrid cloud topologies. The critical infrastructure group and then the network access group cutting across those. And the thinking here is to drive each of those groups from a use case perspective. How would the users of a cloud of that type actually employ the cloud services, drive that through the actual instantiations of the cloud, whether it be with a cloud service provider or an owned and constructed cloud, and then ultimately thread that through to the kinds of threats that might materialize in that environment, leading finally to the remedial actions that might make sense there. So that was kind of the left is kind of the landscape and how we organized ourselves. Then moving to the middle, this is the intermediate phase, or what we'll embark upon over the next quarter of the TAC run for this year. And that's really around identifying the gaps in each of these groups and taking an inventory of the industry efforts more thoroughly that apply to those, and applying them to the definitions already in the industry. The final quarter of the year leading to the end of the year is, of course, what pretty much everyone else has said is, okay, let's narrow all that down. Let's get to the point where we have actionable recommendations and some specific input for the FCC. So the groups have already been running, and they were started down the path of what we have here, which is just basically what are the top areas of concern for each group, the relevant standards, the potential collaboration, and the additional expertise that we're seeing that we need. And we think increasingly, as we heard earlier, we're going to be pulling from other expertise beyond the current TAC just as it currently exists. Next diagram is more for reference than anything else. This is a pulled from a NIST document. This is their definition of the cloud, and you can see that there's dimensions to definition across the deployment models that you see across the bottom, public-private hybrid community. The service models is the cloud actually served as a software as a service, via platform as a service, or as infrastructure as a service. And then all of the clouds tend to have fairly consistent characteristics around resource pooling, elasticity, service measurements, and that was one of the areas that the CSA told us was that cloud service provider, grade of service, standards of service, and quality of experience metrics are a little bit lacking at this point in time. So moving on, we did talk, as I mentioned before, to John Howie from CSA. He's the COO there. And basically, what he told it's a not-for-profit group. We're in the process of trying to get them added to the working group as a formal member. The FCC is working on that for us. They had a couple of things that they showed us. They too are entrenched heavily and guided by NIST as their reference. They have a thing that they call the Notorious 9. That's on the next slide that are listed, and those are what they consider to be compiled on an annualized basis. The general threats, the highest ranked general threats to cloud computing. The interesting thing was he called a very distinct difference between those threats to established cloud users, the Notorious 9, and what they called barriers to cloud adoption. And while you wind up with some of the same terminology, the threats were very different. If you notice, and this is clearly a point of connection back to Russ's comments earlier about there is some symmetry between the groups. The very first threat or concern relative to cloud service adoption is availability and implied reliability there. So whereas you don't see the existing cloud users, if I go to the next slide, the Notorious 9 being on the left, you don't see elements of resilience and reliability and availability there. Part of this may be how they framed the question. We asked John what he suggested we might do, and where he saw the holes in the industry based upon the work that they were doing. And you see some of the ideas at the right. And that's not to say that this is what we've adopted as our working group scope. We've accepted that as input, input from a group that's been at this for a while and has pretty good perspective on the industry. And he did say that network access is a big issue. We'd initially excluded that from just thinking about the cloud, but he pointed us back and gave us the confidence to proceed there. He also pointed out that the industry itself is struggling quite a bit with this notion of regulation. There really is no classic regulation in the cloud realm, and of course, some people view that as a good thing. Some people view that as an opportunity. So we'll see where that ultimately plays out. And the other thing that he mentioned, as I talked before, is he just talked about a little bit about some of the services that cloud access heavily depends upon. It's not just access, but you see things like DNS, border gateway protocol security. Those are all holes that can be driven in cloud services in a very big way. So the next slide just is more of an impact slide. We looked at this is a shortened version of the bodies and entities that we've seen that actually believe they have a foot in the water here. Categorized into 4 groups: U.S. government, state, federal, and local, research and academia, and I'm sure that list is too short, standards bodies and industry associations, and then international entities. And in the backup slides for reference, you'll see the full list with reference of access. Point being is there's a lot going on here already, but it's not clear how cohesive it actually is. Next slide is sort of a gratuitous, breaking it down in terms of the classic building blocks and the threats to actually mitigate the threats. I won't spend a lot of time on this. I think for those of you who've been around this space, you kind of understand. But it's basically, you've got the classic sets of threats like the DOS, the DDoS attacks, the DNS attacks that typically are publicly oriented, compromises from within, and then of course the classifications of threat, whether it's confidentiality breach, the integrity of the data, or whether it's availability. And there's various building blocks that are already in place in the industry that can be leveraged to deal with these sorts of threats. Now, I'll step through each group, about a slide on each, just very, very quickly. The first group was around consumer and enterprise, and as I said before, that kind of homed us more toward the public cloud environment. And here the idea, again, is to start to the left with the 2 classes of users, the consumer user, the enterprise user, drive the use cases or some representative use cases across the cloud. What are the threats that actually are then implied by actually executing a service? The threats and the realities of what may happen are very dependent upon the use case. For example, if the consumer is a mobile banking user, the threats that they would experience would be very different than if they're actually trying to access or buy content. So you'll find that the actual threats and then what that ultimately leads you to, the controls and the mitigation factors, are different for several different classes of use cases. So we felt it important to think about those paradigms so that we had a fairly good rounding of what's going on here. So you're starting to get a sense of the scope of the task. The next group is around the critical infrastructure group and a little bit more around the private cloud. And the reason we thought this was relevant was at our first TAC meeting, if you recall, there was some explanation around the executive order that was issued this year around CI. And the first thing we thought was probably important was to come up with a definition of CI. So we copped out and went to a standard definition because there's a massive amount of debate around what is CI. So we'll go along with the definition that you see here that was actually provided by the Department of Homeland Security. And And there are some threats here, and we've pulled on them a little bit throughout the course of the day here that are different than obviously the consumer and the enterprise threats, and they're different than what the CSA would normally see because they are more focused around the consumer enterprise wide-scale usage. You'll also find that there's some differences here in terms of the potential collaboration activities. There's quite a bit going on here within NIST. We mentioned smart grid, I think somebody did earlier today, and this is another classic case that intersects with critical infrastructure where cloud services I think are becoming increasingly important as well. It was worthy of note that there was almost a direct overlap, at least reading from Charter and some of the findings from a group in Europe called ENISA. So there's a paper that was written by them that we've actually pulled upon so that we don't reinvent the wheel there as well. Group 3 is around access, and I think this is a pretty straightforward thing. Most of us have been around the horn on that a long time. There's obviously the private network accesses, the community network accesses, and then the public internet accesses. Again, those are types of paths into a cloud. Each of them carries their own threats, their own considerations, and their own concern. So we'll start with the basics, the normal paths of authentication, authorization. This, again, pulls on the issue of availability, and this is clearly another point of intersection with the network resilience group. And then finally, what are the data protection mechanisms? Are they intrinsic to the access, or are they expected to be provided over the top by the accessor and the accessing entity? So in summary, where we're headed with this whole thing, as I kind of have alluded to, is we spent quite a bit of time getting our head around it. I think we've got a reasonable plan of attack and a reasonable scoping. It's still a big and daunting task. I expect we'll narrow up some more over the next quarter. Next quarter will be focused around the gap analysis in each. We're hoping and expecting to find a number of common gaps and a number of common, remedial actions that apply across at least the first two groups that I spoke of. And then finally, ultimately, construct a set of recommendations that we hope will enable the FCC to take this a step further. So I'll stop there, Dennis.
Great report. Questions from the group? Go ahead, Jack.
So, and this might be way too specific, so I apologize. It's the engineer in me. When you think about threats, and one of the things that we're having to change our thought process around is today, DDoS gets a lot of airtime. It's by far, at least for public internet, one of the largest challenges. But it's relatively I wrote down my words carefully here. It's sort of in its infancy because it's not very sophisticated, and everything we do and many of us do to protect ourselves and to respond is because the attacks and the threats are actually pretty simple. They have nice patterns. We get to look at it for a while. We then suddenly decide, okay, we understand the pattern and we can do something about it. Here's a thought exercise for the group. What happens when there aren't patterns? What happens when a threat becomes unidentifiable and it is as if it's all just real useful traffic? That's what keeps me awake at night. And probably as these things become more and more sophisticated, we'll have to deal with a more random threat than we are today. And just to throw a number out, kind of scary, and I know the New Star guys see this too. Attacks have gone from a gig to 10 gig. Now a pretty decent attack on the public internet is in the couple 400 gigs of traffic all at once, and that's just growing, and it's growing. It's probably grown by 10x in the last year. So that's a thought exercise for the group and around really identifying the threats specific to public internet.
Yeah, I think it's a great point actually, and I know some of the three-letter acronym agencies that are near here are struggling with that same issue. That what's the difference between random noise and just a lot of it just looks like a lot of the right thing, and I think that does have a place in our cloud security work. So for sure, thanks for the comment.
Other questions around the table? Questions on the phone? People seem to be winding down here. I can't imagine
No,
why.
no,
Russ
hey,
has got
Dennis,
a lot of time
not
available.
a question, but more of a point for Paul. Paul, remember we were going to discuss a little bit about the accountability and some of the responsibilities across the different domains here. I wonder if you might want to, since it's kind of hard for me to speak on this side, maybe you could take a shot at that.
Yeah, that was another thing that John Howie had pointed us toward, was that when you get so many pieces in the food chain and you've got cloud as a service, it's hard to identify who's accountable for that service in the end, because you've got maybe the hardware coming from a different place than the software coming from a different place than the actual cloud service provider, than a different place from the accessing mechanisms. And so there's a real challenge in accountability, to Harold's point, in terms of threading across, okay, who's ultimately responsible for the security of the service and who's responsible for the integrity and the resilience of the service. So that was something that John had scoped us in on, and that is probably, one area, to Harold's point, where we think there's an FCC hole to plug, because we haven't found anybody in the industry, in spite of all those acronyms and agencies and and groups, that are really thinking about the whole picture. So thanks, Harold. That's a good point.
Great. Russ?
A quick question on how much effort or concern do you have about what I would call the machine-to-machine and the, quote-unquote 50 billion devices being connected to the network?
Yeah.
A lot of those are going to get their policy pushed down or checked at the cloud, in the cloud on different services, and just wanted to get your input on how much of a threat you see, or do you see any area for like standardization of some type of base security for devices like that, especially even just between machines?
Yeah, it's a good question, Russ, and that's one of the reasons why we pushed the critical infrastructure sub-working group in there, and M2M, Smart Grid was the poster child for that in the presentation, but M2M is the more general way to look at that. And I would just stretch your comment a little further. I mean, certainly the policy is going to come down to from the machines, from the cloud, but the machines increasingly, as they get smarter, reporting into the cloud as well. So I think it's a fair point. I don't know of any standards there. Probably the best we can do right now is look for a landscape and see if we can make some recommendations. So thanks for the comment.
Mark?
Are there issues with the limits of the FCC authority with respect to some of the infrastructure that has responsibility here? A cloud service is, today looked at as an endpoint. It's a customer premises equipment. And we've deregulated that. We've made it out of scope of a communication service. Where are we going to have problems that we're investigating issues which ultimately the FCC has no authority to deal with?
So we've talked about that quite a bit, actually, and it's a fair question. I guess the way we're looking at it right now is the world is changed quite a bit, and there's clearly a critical infrastructure component here, and there's clearly a communication component of what's going on here. So, I think what we're going to do, actually, to be honest with you, Marvin, is play it through and identify what we think is the best action that somebody could take, and honestly leave it to the FCC to decide what they can and can't do. But it seems to us that regardless of what the FCC has statutory power to do, some of the issues that I think will surface are relevant to report on in the industry, and I'm sure the FCC will figure out a way to act on as much of it as they possibly can.
Any other questions or comments from the phone lines? All right, Shahid.
Paul, you may want to consider this notion of cloud broker. Increasingly, as enterprises are looking at various different options, whether it's public, private, or hybrid, they may end up getting resources from several different clouds, if you will, right?
Yep.
And this idea of having a broker and managing those transactions could also be leveraged for the policy management, right, and security and those kinds of things. So I don't know if you've looked into that or not.
No, we haven't. It's a great point, though, because from the perspective of security, it's also another hole in the waterfall here. So it's a good point.
Russ, you're back.
Quick comment. You may want to follow some of the work Addis is doing. They're actually looking at how to exchange information between clouds, metadata, different things like that. And the biggest concern is both the policy and some of the security aspects.
Oh, yeah, sure. Makes sense.
There is an ADIS working group.
Okay, thanks, Russ.
I'm delighted that this was a technical comment because I'm worried about the specter of you and Paul joining forces and truly taking over the time.
You know, we should take the union of the groups and see if we have it.
We brought these two groups together.
We might have it. No, I don't think so. Not quite.
All right.
Our next meeting's in Hawaii.
I like how you think.
I got it. Now we understand. I usually don't call on people, but I'm surprised at this topic that David Clark hasn't come up with a comment. It just seems when we're talking about the cloud and security, it seems somehow that you are going to tell us provide us with some pearl of wisdom. So.
Well, actually, I wasn't. I'm on the resiliency group.
Okay.
No, I really think the answer is scoping what you do, because there's an awful lot of people looking at these issues out there now. There's all kinds of people, and a lot of discussions about security have this timeless quality, which is to say you can make recommendations and they're still valid 5 years later because nothing has changed. And so I really do think you have to focus down on what advice the FCC needs, which is different than what they have the authority to do, because they can exercise other roles other than regulatory authorization. But I think you really have to focus down, okay, what do we need to tell the FCC in this space that NIST isn't telling the cloud guys and the cloud guys aren't telling NIST and so forth. It's a big, messy, multi-dimensional space, and as you say, the issue of divided responsibility is a real part of the problem here. It would be simpler if there was Ma Bell running the cloud, right?
In some ways.
In some ways, yes, I am.
Thank you.
I was not disappointed. I anticipated a pearl of wisdom, and you certainly provided it. Very good.
Russ, to your question on MTM, there are 7 SDOs that are working in this space. One of them is TIA, ETSI, NIST, and TIA has a pretty mature standards that you can buy today. Okay, and it's very well thought out. And I was wondering, Paul, if you could perhaps provide some directions to Russ on the scope of cloud resiliency, perhaps.
I'm sorry, I didn't hear your question. I'm sorry.
Do you think we should provide maybe some assistance to Russ Group on the big question of cloud resiliency?
Yeah, so to the extent that we're worried about resiliency and cloud resiliency, there's clearly a great deal of overlap and discussion between the two groups. To the extent that we focus on security and only cloud security, that may be a little less so. We'll still have some places where we touch. So we should probably talk and decide if we want to bring that into focus in the two groups or not. The resiliency piece. Probably need to get some counsel from the FCC liaisons as well on what they want us to do there.
I think it's a critical part of resiliency. We've been focusing a little bit, especially on the talk today, on the physical sort of part of the network, but I think it's a clear, hopefully we have time to get to that issue. By the way, the other group that, I don't know if they were included in that, there's an effort called One M2M, which is also looking at some of the standardization of how to deal with machine-to-machine, which is kind of interesting, which you might be interested from your perspective.
Great, thanks.
Okay, the one final comment from me, and this is one that I made actually almost a year ago, and when we were addressing security in another fashion. I think the classes of where the attacks come from is something that you may want to look at, because there are enormous range of kinds of issues in the security space, and what their targets are and what they're trying to achieve. But putting some structure into that space,
that's good.
Would be quite helpful. Certainly, you can draw on a lot of the organizations that you've listed, but that framing it might be quite helpful.
Thanks, Dennis.
All right. I don't see any more questions, and that's good because we're getting right to the end. We started on time, and the goal is to end on time, keeping up the tradition that Tom established for us. I did want to just give a couple of comments at the end, and the first one is, and I had to even write it down, was wow. If you think about what we've just covered in the last 3 hours, the scope of the activities that are being undertaken by the group, it really is an extraordinarily broad swath of extremely deep and important issues. And for me, it's really quite impressive. And I have to admit, moving into this chair from the work group chair maybe focused me a little more broadly, but it really is quite impressive, the work that you all are doing. And I think that since you, perhaps like me, were more blinders on, take 3 steps back and think about what we've covered this afternoon. And it really is an impressive scope and really a high impact scope. So I'm really impressed and pleased with what's underway. To be sure, this is the mid-year connect, and the real deliverables come about 6 months from now. And we have set a lot of lofty goals and a lot of work to be done to get there. But we're really on quite an impressive path. So thank you for that. Couple of other items. I would like to recognize again the staff contributions, the FCC liaisons. They do, speaking as a working group chair now, the FCC liaisons do make the working group chairs look good, and the working groups themselves. So kudos to each of the folks that have contributed so much. And I won't reiterate your names again because they were recognized in each of the reports, but it really is terrific work. I will give Julie the opportunity to provide any final words if he'd like to do so.
Yeah, we managed to time this terrific. The storm is just coming inside the Beltway.
In fact, Julie, show everyone what you have in your screen there.
Here's the end of the world. This is the result of all the terrific work we're doing in communications.
Yeah. It really punctuated the resiliency group for sure.
But I do want to thank all. No, it's coming.
Here.
But I did want to, just on behalf of the Commission, thank all of you for your work. We know you all have a day job and a night job. So it really do appreciate all of the contributions. And I want to thank Dennis for standing in today, because it was a daunting task to pick up all of this, but you did a fantastic job, and we really appreciate it. And so thank you.
Now, with this group, it becomes an easy role, so thank all of you is where that really goes. Michael, speaking of people who stepped in, Walter is not here either, so we have multiple steps in today. Michael, any final?
No, I think everything went well. We had a little trouble with some audio-video equipment, but staff handled it really well. And Dennis, maybe we hope to see you again in September.
Well, that has been with the confirmation hearing, that will likely happen, so plan on that. Just to remind you all, our next meeting is the 23rd of September, same place. So presuming that the world doesn't come to an end based on the pictures that you've all been looking at, we will all look forward to being here on the 23rd of September. And with that, otherwise, enjoy your summer. And since I know that you'll have extra time with especially academics, we're in this great time, so you can put more dedicated effort into the TAC, so it's perfect timing. So with that, we're even going to end 2.5 minutes early. So thank you all.